Deternary raw footage starting now. Okay, it's final level. Deternary. That's my mic, by the way.
Oh.
just so you know if you're putting stuff.
Yeah.
Sound effects of wind 01. Okay, cool.
Oh yeah.
Let's copy the level.
Wow.
And then display. Oh my god. Okay. The edited. Oh, here we go. Okay, documentation. Deternary is a computation machine emulator. The idea behind this emulates the operation of a Comchion machine compute. I don't know what that's meant to say.
Oh, I think that's supposed to be a P.
Yeah.
I don't know. Whatever.
They use ternary. Yeah.
Yeah,
so
cool.
they use 101. We got 012. Let's just take the machine so it's literally used to understand what we'll be working with. Accumulator, also accumulator. Okay, cool. Instruction pointer, instruction register, address register, data register, stack pointer. So this is just a CPU.
Cool.
ALU. So that's the result of the calculations. Testing system. Input output device. And this is memory. So this is memory. Each one does in order. Accumulator. There's a value ALU, just like the operation. So yeah. Instruction pointer shows the instruction address the machine is currently pondering. So that's in here.
I like the use of the word pondering.
Yeah. The instruction register shows the instruction itself. So this is the instruction. This is where it's pointing to a memory, and this is just this. So this is just showing the current where we are in memory.
Yeah, I think so.
Address register whenever the instruction tells the machine to find a cell as a certain address, this register will store it for future data extraction. Okay. So this is so this is the MAR.
I see, yeah. And then the
this
data
is the
register,
MDR,
MDR,
This is the data from the thing. Stack pointer technically points at the next free cell. You know, they should get us to do this in computing.
Yeah.
We should get this on the A-level syllabus. Technically points. Why I say technically? Points to the next free cell in the stack. Practically shows how many values are currently in the stack. Cool. So that's our stack pointer. Memory contains all the data. Whenever the machine reads a cell, it tries to interpret it as an instruction. Okay, so all memory is instruction, no data.
Awesome.
Memory is built in the von Neumann style.
Yeah.
So we can have data instructions, but be careful because I guess so. It's saying anything you store will be interpreted as an instruction, even if it's data. Why would you store data? I guess we'll see. Input device sort of value that would be read by the machine as input into the accumulator as soon as the respective instructions are read. So when you put into the accumulator, and then you just...
Oh, it's like LMC where you need to have like constants like 0, 1.
Yeah, exactly. Output device stores and shows the most recent value of the machine printed, so when you put out, respective instructions called. ALE, it goes behind the ground. Oh, I can toggle off show ground, right? There we go. Oh, why does the text toggle off? Okay, ALE, after every arithmetic operation displays two flags.
And signaled by the state of the accumulator. What for comparisons and computations?
I guess. First indicator will show nothing.
Wait, scroll around. It might. Oh.
No, maybe it is the first indicator will show nothing if after the operation the accumulator is 0, and that's also nothing. Oh, these are the symbols. It's because I'm in preview mode.
Oh.
Wait, let me turn on preview mode. What? I feel like there are meant to be symbols there. It's a little bit worrying.
We'll figure it out.
Okay, I'll turn off preview mode again because it's a bit easy to... No, there's nothing here that I'm not previewing. Okay, well... Is it easy to read in preview mode?
Slightly.
Okay, cool. I think it's harder to read. If it's above... And again, nothing. If it's above 0, I guess we can get the document for that. Second indication will show something if nothing strange happens.
Something strange.
Question mark if the operation caused the accumulator to overflow. Doesn't happen often. And again, something else if underflow. Oh, there's our list of instructions.
Cool.
But I see the symbols in here.
Yeah.
They're like quite subtle on this background.
Okay, so that's why the
is
you gotta pull up
is
the
that really
spreadsheet.
So there's definitely nothing in there, but every memory cell and register can maintain values from 0 to 3 to the 9 minus 1. Is that 2048? Really?
Yeah, that's crazy.
What's 3 to the 9? No, that's 19,683. 19,682. That does not sound like the guide we read. Well, like it makes more sense though.
Yeah,
Because it's ternary. So about
Yeah,
I don't know if that's 3 to the 9 minus 1, or because they would have just rigged.
No, yeah, it's 3 to the 9.
3 to the 9. Okay. Let's get into things you can put in there. 1 instruction per cell. First glyph is the instruction. The other 2 are taken as address or data to operate with. Okay, so everything's 3. So the first digit is 1 instruction we're doing, and then address, and then the data or address. So it's like addressing memory. Tables will also help associate digits 0 to 26 to the this table. Which table? Table. I feel like we're missing stuff.
Wait, the table to the right? Is there stuff further right, or no? That's the task.
Okay, none. Oh, here we go. We'll definitely need a document for this. This just means none.
Okay.
This is in. This is out. This is load. This is set. Well, we know these.
Oh, such a beautiful instruction set.
Load set. So what's load and set? Lower 2 trites as an address. Load the value from there to the accumulator. I see. So you see how these 2 are always the same?
Oh yeah.
So this first symbol is the thing that dictates the instructions. So
I see. Yeah.
It's load this. So these are the lower 2 trites.
Yeah. So load the data.
This is load from this address into the accumulator.
Yeah, I got it. Yeah.
So this sets as an address and sets the value in there to the accumulator value. Awesome. Add the lower 2 trites of the instruction to the accumulator. So you take accumulator.
So that's immediate.
This is immediate adding. Yeah. And then immediate subtraction. We got a multiply command. And we got a divide command.
Look at that.
Easy. This is gonna be so free. Uload. Use the data the instructions pointing as the address. This is
indirect.
This is direct.
Direct.
This is direct. No, wait. Because immediate would be the data you're given is the data. Yeah. Direct is the data as an address. This is direct.
Yeah.
This is indirect because you go to the address and then go to the next address. This is indirect. You load and you set are indirect load and set. This is add. This is direct add instead of immediate add. Yes. This is direct add instead of immediate add.
Cool.
Sick. Direct sub, direct mult, direct div. So these are immediate of those, and these are direct of those. Jump. So this is a branch. So there's a branch. There's a branch always. Jump Z. Oh.
So you can detect overflow. Okay.
The F flag.
I think that's the overflow flag.
I
don't know.
I don't know what the Z and F flags are.
I think Z is the comparison flag. Like, when it's like it was talking about this flag will be, I don't know what the symbol is, if it's greater than 0 or whatever.
So the first and second indicator.
Yeah.
Is that one of the, or are these just going to be like these? No, where's the indicator?
I don't think, is there a... wait, those things?
Wait,
maybe?
This is the text from the document. Wait, we could just look at the document?
Oh, this is looking at the document.
Wait, let's look at the document. I can't select, but we can
just type that out.
We can type this out. bit.ly / it's a bit a lot easier to read. 4DIX capital VYJ is preview continue destination.
Awesome.
Deternary documentation. Okay, this will be a lot easier. Level ID updated. Yeah, what the hell is going on? What am I doing? Computation machine emulator. Yeah. Okay, so we've seen this.
Oh, and then we got our diagram.
Same thing, input device. Yeah.
Wait. Can we see what those symbols are now?
Mm-hmm.
Yes.
There we go. So we'll show circle if it's 0 and line if it's above 0. Circle, triangle. Okay, up arrow, down arrow. Yeah. So it is 19682 and 19681. No negatives though, so it's unsigned. Here we go. Okay, cool. What is this?
Flavor text.
Take the data to the instruction just to the point to another location. Take that location as the one that's led the value from. Caught that. Basically, yeah, it's indirect addressing, bro.
Bro does not know.
Z flag, F flag, still not explained, but we'll probably. Yeah. No. Sorry, that's bad. First indicator. So that's in the ALU. Oh, I understand. So that's these. these flags. Oh,
yeah, that's what
it's these. Yeah. Okay, cool. I still don't know what the testing system is.
I think that's for our tasks, so it will verify if the task is complete or not.
Cool. So we got Z and F flag commands. Comp. So the Z and F flags in the ALU as if you performed subtract with the same address without changing the value in the accumulator. So that's like if we need to change the flags, but we don't want to change the accumulator value. So it's like compute to update our flags so we can do our jumps, I guess.
Oh, I see. Yeah. So you can do the comparison without changing the accumulator. Okay, so it's like if you're doing subtraction or whatever, you can also use the flag after that as like a 2-in-1 kind of thing. But this is like specifically computation without doing
just for the flags.
Okay, cool.
Push the accumulator value into the stack, adds 1 to the stack pointer. That's your thing. You're good with stacks. You use Linux. I'm bad. Next stack size is 27. After which push instruction will be ignored.
Cool.
Pop from the stack. Extract 1 from the pointer, receives the most recent value. I assume that puts in the accumulator.
Probably.
Retrieve. Yeah. Push the current address to the stack.
So basic cool. And then you use return, and that'll pop that from the stack and go back to where you were executing.
Cool.
That's basic functions.
You got that. That's your area of expertise. Swap the accumulator value with the top of the stack. You can use this to swap is very strange.
You can use this to return values from procedures.
Like swap, push,
I see.
So, I think I get that. If you have trouble referencing which cell does the instruction operate with, memory also displays addresses on the left side of the memory block. Those numbers should exactly match the lower 2 trites of the instruction that operates with them. Total number of memory cells is 729.
I can't believe they built computers. We've just been glossing over that. That's pretty cool.
Because the video the guy was talking about, he was going to do it in 2021 but couldn't, so wait until 2025 in 2.2 when it was a lot more possible. Now what are you going to do? To write code, you can move through the tab in the instruction pointer, which says player 2 left and right. Changing the value in the instruction register will change the instruction at the
current location. Okay, so you can just edit the... When you select a location and you can just type it or...
My brain's exploding. We'll have to see in the lab.
I think this is a start and figure it out kind of thing.
If you move a bit more, you'll notice you can access the input device but can't change the input value. That's because it's only possible when the machine asks you for input. Cool, makes sense. Running the code is possible by navigating the instruction pointer to the address you want to start execution from and pressing P2 jump. To stop the program, hold P2 jump for 1 second. Speed up the running process. Hold P1 jump while the code is running. So that's why the guy was holding P1 jump the whole time. Gee, because it makes it run faster.
Yeah.
Because that seemed like that task 5 took a long time to execute. Testing system contains 5 test groups, each one for a different program or task. You can turn it on and off with P1 jump. So we got an IDE. We got IDE system. And when it's on, instead of the machine waiting for you to input something into the testing device, the testing system will do that for you. Then it'll wait for the code. So it's like automatic input. And if the output is right, you'll see the input progress to testing to get it all lights out. So it's saying if this was my input, would the output match my output? And then we got this. Okay, I need to make sure I can trust you. The first 4 tests will be the same. Me testing your code to make sure that it works. The 5th test will be different. During the 5th test, I will swap the instructions for 2 instruction codes in my architecture. Your code will break and fail the test if you run it unchanged. Do not worry, I will set you back to test. I will not set you back to test. You're also free to disable testing your code on this testing stage. I will not set you over that either. To find which 2 instruction codes out of 27. Oh, okay. So once you do the first 4 tests, 2 instructions get swapped, and you have to find out which ones they are.
And then fix the code. I see. That's just mean. That's just mean.
I will do that for each one of the tasks. What?
No.
No way. That's a coin. Oh, whatever. Well, we'll see. Oh, because there's 0. There's a task 0. Wait, but it says the first 4, and then it says it keeps going. So it doesn't make any sense. Right. Oh, tests.
Oh, I see.
So it's like every 5th time you run your code.
No, but you can disable it.
Oh, it's in the testing system.
Yeah, so
you can just not use the testing system. Let's just not use the testing system.
That's long. Yeah,
maximum of 2 and for 2 numbers. Yeah. Square root. And 2 just want to go.
Yeah, that's good. Let's
just see what happens. I'll delete this because you got the document. Okay. Deternary. It's time.
Awesome.
Okay. I'm gonna make sure I'm recording real quick.
Whoa, they got graphics.
Okay. So P1 jump. We can go around, and these are the ones we can edit. So if I go back to the document, we can edit. So we can edit the instruction pointer and the instruction register.
Okay.
Sure. And we can edit input. That's all we can edit for now. What's P2? P2.
Okay, so our instruction pointer, yeah, we're selecting what instructions said, yeah.
So I see. So if... I think I just ran the program.
Yeah. It's just... Wait, you can cancel, I think.
Yeah, I can cancel.
Cool.
Oh, how do I undo this? Oh, shit. So this is P1, I believe, and this is P2. Yeah.
Cool beans.
So currently we're just like running through memory if we run this.
I assume this instruction is just a no-op. It just doesn't do anything.
Yeah, that makes sense. So how do we change which command we're doing? So the way we change the data is we literally just P2 move through.
And then we edit that, I think, when we're on our correct memory location.
Let me find it. Because I think it said, okay, to write code, you can move through the tab of the instruction pointer and the instruction registered.
What? Tab is like the selected,
I see.
yeah.
So you can move through the instruction pointer, instruction register with P2. So this is P2. I have flip player, so yeah. So arrow keys is P2, so that moves the instruction pointer. Changing the value in the instruction register will change the instruction at the location of the pointer in the memory. Okay.
Wait. If I do this and then increase the value, yeah, it sets the value at address 2.
Wait, because we're changing memory right now.
Yeah. Okay, I see.
How did you do that?
Well, we're on number 2, and I selected that, and I just pressed that up arrow.
Press the up arrow.
I think. Wait.
Yeah. I think you jumped. It's because the thing is, we've changed memory now.
Wait, how did I?
Yeah, I don't know how you did that.
What?
I think you jumped.
Because. Oh, okay. So it's.
I think I've reset back to normal.
Cool.
No, no, I have not. We're in like edit mode right now.
Yeah.
How do I get out of edit mode? This is the testing. No.
Wait, scroll up to the diagram.
Yeah, that is. I swear that's like the testing. Yeah, that's the
testing system.
That's if testing system is on or not.
Okay, that's on.
But we're in like a mode right now.
I think this is edit mode.
Yeah, we've entered like a different mode. You can access it. By navigating the instruction pointer to the address you want to start execution from, and you pressed P2. No, that was what we did before. How did we get into like this edit?
That's the tab thing with tabbing across the registers.
Yeah, this is P1 jump.
Okay.
This is the entering testing mode.
And then.
Oh, but was it just because?
Wait, was it? Yeah.
But whether I'm in it or not, it's still doing it.
What?
No, this is normal. This is normal.
Okay. Cool.
Yeah. Oh, it's just because when we're on row 2, we're changing memory. When we're on row 1, we change where we are in memory.
Okay.
Because this is the pointer,
the instruction
and this
pointer.
is the value.
Yeah.
Okay. I see.
Should we make a quick take an input, add 1, make an output to like?
You want to do that?
Get.
We get just in, add 1, and then out. Okay, let me find in.
Okay,
so
it's like the 4 character.
Do you want the keyboard?
I I don't know how to use this editor. Okay.
Yeah. So this is in.
Wait, no.
Let's test mode.
Oh yeah.
So you're changing memory values right now. Left and right. So wait. Let's not change anything right now. Let's leave everything normal. So this is 0.
These characters are upsetting.
This is 0. That's 1.
That's 1. That's 2. Oh, I see. Yeah. Fine.
Oh god.
This is so annoying.
Should I get some paper? I have paper.
TS PMO.
Hold my drink.
Yeah.
I can't put it down.
Hold my beer.
Let's get paper. Let's get stuff. Start taking notes.
Okay. So then, if we underflow, like that,
Yeah,
that should be
flags.
faster. Wait, I think that's that one. Okay, these characters do not match what I'm seeing on this spreadsheet.
No, because those are the ones that go up to 27. Those are the symbols that represent.
I see.
Those represent our instructions.
Oh, yeah.
So remember, when you're changing.
Right.
When you change number 1, you're changing the instruction.
Oh, I
when you
see,
change number
yeah.
2 and 3, you're changing the data.
Right.
And you see, so yeah. Okay.
I didn't get that.
So let me get this down real quick. So this like
Write that
weird
down,
N
write that
thing.
down.
Write that down. This weird like N thing.
That's 0.
This is 0. Then I believe that is 1.
Ah, yeah, sure.
Is 1, and then all
That's-
the way down.
oh.
You moved over by
Okay,
2.
okay.
Yeah. So all the way down, and
that's 2.
Is 2.
Cool.
So if we get confused, just quick reference.
Hold on, I've got to pull out the calc.
Okay. Yeah, get the calc up. We gotta get used to Deternary here, and then these go up to 27. So
Oh, by the way, chat, if you didn't know, calc stands for calculator.
Yeah.
We're just using
These days.
slang.
Okay, sick. Okay, so let's get an input. How do we get up to? Yes, this is input. This is input.
Right.
So this is in, and then if I move over, and then input 1.
Yeah.
Is that 1?
Wait.
I think that's 1. Because I think these are 27.
Oh, yeah, because first instruction, 1, second, third, fourth.
Exactly.
Yeah.
But I think this means input 1 because I think this is 1. I think each of these digits goes up to 27.
Yeah. And then that's, yeah.
What's 27? Wait, what's 27 times 27?
100.
Yes,
729.
because they said everything can go up to 729.
Cool.
So I think each of these digits goes up to 27.
Does input just ignore these two then? I assume.
No, because input is input. Oh.
I think it must just ignore those.
I know what you mean. Yeah, no, I think you're correct. Sorry,
They just
that's
don't
my
do
bad.
anything,
My
yeah.
bad. So input. So we got input 1. Let's move over to
Awesome.
this.
Right. Yeah.
So you see how when we move down.
I understand it now.
Okay. Input, and then read the value from the input device into the accumulator. So we input a value, and then we didn't add n. Let's get an instant add. This is our. Oh, I moved over to. This is our instant add, and then let's instant add.
Wait.
Oh, did I?
That's. Oh yeah, no. Yeah.
Instant add. 1.
Okay, and then
then-
out.
No, sorry. And then we'll get used to this. Move over another 1. And then out is 1, 2.
What is the output? Oh, is that the output device?
No, that's the accumulator.
Wait.
This is the output.
Oh, I see. Yeah.
In this
Input, output.
So
Yeah.
now, how do we execute? So
Wait. You forgot the whole. The whole is very important.
Do we
Otherwise,
need
it will
a
just.
whole?
Well, otherwise, it
true,
will just
true,
go
true,
down.
true,
No.
Okay, thank you. Okay. And then Holt is 27, so it should be that. Let me fact check that.
Ooh, ball knowledge. Yeah, because 0.
26. Okay. And now, is it P1 jump to start?
Wait. You need to go to the first instruction.
Okay.
To start executing from there.
Sure.
And now we've got to input, maybe?
Yeah, I think we have to.
Oh, yeah.
Yeah, okay, let's input. That's 1.
1. And then we should get.
And then it should
Wait.
output that,
Cool.
which is the same as our. So we're putting in 1, which is input, and we should result in 2, which is output.
Awesome.
So we're putting in this, and then I believe, which is submit. How do you submit an input?
Maybe tab off of it? Oh, I don't know.
How do you submit an input? Input device. Let me find. Okay. You can't change the input value. Yeah. To stop the program. I don't want to stop the program.
On. Yeah.
How do we submit an input?
Wait, why is this the hardest part?
I mean, the hardest part is. Oh! I just had to go back there. Output devices 2. Output devices 2. We got it.
We're locked in. Okay.
You can't just like select all code, delete. We have to go manually delete all our code now. Okay. So how do we start a task? How do we know when we're like doing?
I think we turn on the testing system, and then it just. No, wait.
Oh, testing system contains 5 test groups, each one for a different program task it has to test.
You turn it off with pin.
Yeah. So right now we're in debug mode where we can do anything we want. But if we turn on the testing machine, we have to do one of the tests.
Okay. Wait. Turn on the testing machine on our program. Wait. Go up to the.
That's the testing machine.
Go up to the start and see. It should like show us failure or something, maybe.
Yeah, sure.
How do
now
we?
let's. I believe I have to go here and then we have to run. Oh yeah. Because.
Yes.
Yeah.
And then
failure.
Cool.
Okay. Sick. So we can't edit the input device right now. This is just what it's showing. Is that the default? Let me check if that's like the default that it shows. It's not, but hopefully it'll reset next time we do anything.
Yeah, it should do.
Yeah.
Okay.
Should we go?
Let's
go undo everything.
Undo.
God, undoing is gonna be a very
bigger of 2
part of
numbers.
this. Yeah.
Okay, so we have to use the comparison operation here. In fact, I think we just subtract. We subtract and then we use the flag things.
Okay.
So we need to get our first number, store it somewhere, and get our second number.
We need an input.
Boom.
We need an
Okay.
input. Okay.
Right now, how do we store that somewhere?
So we input and then set as an address. Set the accumulator value. But the thing is, we're also running through memory as our program, so we need to store like later in memory.
Ooh, yeah. Should we pick a? Should we pick an address to?
We don't want to go
store
too far though, just because we have to like navigate there every time. Okay, so let's input, and then let's input over in like.
I just hold the button until it.
I don't want to though. I mean, I guess we could input like the bottom of our memory.
Let's index backwards. Because then it'll be like the first input, second input.
It's definitely not a bad idea. It's just going to be annoying to like check it every time.
Oh yeah, because we can't go like.
That's what I mean. So I don't want to go past the bottom here, just for convenience, because this program shouldn't be too long.
Do you reckon we can fit that? Yeah.
I think we can.
Yeah, we can fit that.
We only need 2 to store. Let's store down there. Okay, so
we
this
need
is
2?
our...
I don't think so. We just need 1 because the other one can live in the accumulator.
Oh, and then we just subtract 1. If it's negative, we'll need some.
Do something or whatever.
Well, we can't have negatives.
No, but it'll be the overflow. Yeah,
yes,
the underflow
I see.
flag.
Yeah, okay. That's again. You understand that better than I do. So that's so we got set command, and then we need to go into address. This is still 0 out of 27, and then we need to increase this until we get to the weird like S thing.
Oh, yes.
Cool. We're storing the bottom now. Cool. So that is store in S. Okay.
Okay. Now we need our second input.
Now we need another input. And now we don't need to store. We just need subtract, but we're not instant subtract. We need direct subtract, which is 12.
Cool. No, we don't even have to do. Yeah. Okay.
Yeah. So that's direct subtract of. We need S. Yeah, S. So that's direct subtract of the memory address in S, which will be our inputted.
Okay. Now, if B is bigger, then underflow will occur.
So that's
Oh wait, no, I
Jump
think
if
wait,
the
I think we do
F
need to store our other one because we need to output it again after.
True. Okay.
Oh no, wait, but can't we use the comp? And it won't. If we use comp, it will do the same as the. Yeah.
You're so right. You're so right. Okay.
I'm locked in.
Nice one. Yeah, you are locked in. Look, I got the basic program maintenance. You got the actual like flag stuff. I think this is a flag from before. It's fine. It'll overwrite it when we get a new flag. So now we need a comp command. So we don't need a store. So we got our. No, but we had a subtract.
Input,
so
store,
we did subtract,
input,
but instead of subtract, we want comp.
Well, let's replace that.
So
with
let's
comp.
edit our subtract to be comp, which is 20. So we just need to go like 8 further. 1, 2, 3, 4, 5, 6, 7, 8. That should be comp. Yeah, it's comp.
Yes. Okay, right, and let's see. Set the Z.
As if you perform subtract with the same address
without changing the value in the accumulator. Okay, let me have a look at the flags real quick.
Flags have been set. So it should be jump if the F flag is 2. I'll scroll back up. So second indicator F flag will show if nothing strange happened. Up arrow if the operation caused the accumulator to overflow. Which is like if you add above 2047. Down arrow if it underflows, so if you subtract below 0. So that's all we need. So we need F2, which is jump UF. That's this symbol, which is 19. So we need to now jump UF. So if there's an underflow, we'll jump like here. So this will be So okay. So we got number 1. We got number 1. We got number 2. We subtract.
We're subtracting. Let's call it A and B.
A, B, but B is in the accumulator. We subtract A from B, which if that underflows, then A is bigger.
Yeah.
So we jump to B output. So this is A output, the jump, but if it doesn't jump, it's a B output.
Yeah. Okay. So then we.
So if it doesn't jump, it's just output current accumulative value.
Yes, I think so.
Because
we can run the test and see,
exactly.
and then if not, we swap.
Yeah. So comp.
Okay, so we need to load.
Jump UF. Well, right now we need to jump UF.
Oh yeah.
Is it that one? Yeah, jump UF. So if there's an underflow, jump to. I'll give us 2 lines because we should just need an output halt. So I'll say jump to that
one,
which is that symbol.
Cool. Okay. And then
if we don't jump.
No, but we need to. Yeah. Do we need to load it?
No.
Well, because we've got B in the accumulator. So
yeah, but if there's no underflow, then B is bigger.
Yeah, cool. So
which we already have.
So then let's do our output and halt.
I'm very glad we did A-level computing, otherwise we would not have been able to do this.
Yeah, I feel like we have a slight advantage.
Yeah, but we're still struggling. This is cool.
This is awesome.
I love this. This is actually so sick. I wish if we were still at school, we could have like showed Mr. Skelly.
Yeah, I'd be like, yo.
That would have been so sick. Okay, just output the accumulator value, and then halt, which is
26.
26. So that's halt.
Awesome. Okay.
We'll move one more. This is where we're jumping
we need to load, I think.
Yes, we should need a load, which is 1, 2, 3. Load from S.
Which
is A. Oh, I circled around. Whoops. We'll learn the character set eventually.
Yeah.
S, and then. To be honest, we should probably be looking at these. This is 1, 2, 2, which I guess is 20. We could have a translation for that. We could make some code.
Yeah. 5-hour coding session for
our coding session. We got a code for our coding session.
Exactly. You've got to make the tools to make the tools.
Exactly. So we've loaded. Then we need output. 1, 2.
And then hold. Boom. Okay.
This is making sense. This is making sense. Okay.
Right. Put the instruction pointer all the way up there, and then let's run this thing. Test mode on.
Okay. I just realized we got some random ass input. What am I changing? I'm not allowed to change it because we haven't had an input yet. We need a run. Which is this.
Yeah.
Oh, we need testing mode.
And then run.
Yeah. We need to be up here to run.
What does that mean?
Oh, I think that means we did it. Because there's 1, 2, 3.
Oh, yeah.
That means we did it.
Okay.
Let's go!
Wait. But does it reset us back to, Wait. If we fail another test, does it reset us back to 0? So do we need to write this down?
Ooh, maybe. Do you want to take a photo? I'll take a photo.
I'll do it.
You sure?
Sure.
Well, we'll both take photos.
Yeah.
Just make sure we got it. Okay, cool. I got a photo. I'll also take a screenshot in game. Okay. So. That's fucking scary. But that was why we can do it in not test. We can do it debug mode, make sure it works, and then do it in testing mode.
Okay. Right. What's the next task?
Okay, son. It's down now.
Yeah, I'll put it in the bin. Oh, you know what? I just looked over. Why did you put your bin on your head?
No, it's not because I need to recycle them, so I need to...
Oh, I see, yeah.
Okay, so... let's look over at the testing thing again. So it seems like... when it's on, it'll wait for the code to... Next test indicator... Oh, you need to test it with multiple different, like... Then it'll wait for the code to output everything at once, and if the output is
right, that's why we moved to 4 and not 5. I see.
Oh, so it's like you need to do 4 tests to make sure they all work,
right?
And then the 5th test
is like the swap thing.
So right now we just need to run it again, right?
Yeah, try it. No.
Oh shit! My bad. Okay. Oh, I can speed it up.
Okay, now
again?
No, you've got to bring the instruction point.
Okay, we got it. I'm speeding up. Okay, run it back. Sick. That's 1, 2, 3, 4. Okay, now 2 instructions have been swapped, but they might be instructions we're not using. So let's just see if it works first before we do anything. Let's see if it works.
Is it the same ones every time? I assume so.
That was bad.
No, because it's 2 instructions. Like this character will be a completely different instructions. Like the instruction set is swapped, not like the.
No, it says during the 5th test, I will swap the instructions for 2 instruction codes in my architecture.
Yeah, so like.
Yeah. So it's saying 2 of the instructions we're using have been swapped. And you know what? That sucks.
Okay. Wait. What is it? We've got the same input and output, right?
Wait, we can turn off testing mode, right? During the 5th test, do not worry, I will not see you back to this one. You're also free to disable testing your codes. We have to we can find it in debug, but then we need to like delete all of our codes. I don't really want to do that.
That's long.
But we can turn off testing mode and then we have our own inputs. See
it
stays. So okay, let's reset. Oh, but I can't. Okay, let's. I'll go back to this. Let's run the program.
Now we input.
No, surely we need to compute something. Okay, now we need an input. I don't know what our first input was because it just had something. So it just inputs something. So this is going to be like 1.
Okay, wait. Did it skip the input? No.
It did.
So maybe it's the input code has been swapped with something else.
Oh, input and comp have been swapped because right now we're on comp and it's input.
Yeah. Oh. Okay, that's that easy.
So input and comp have been swapped. Let's input. Let's input this. Yeah, input and comp have been swapped. Okay, so now, assuming that's correct, we just need to go back here and then change the values for these to go from input to comp, which is 20. So this needs to go to 19 more, which should be 122. 122. No. 122's S, which is 17. That's comp.
Okay.
So 202 is 20. We'll learn that eventually. Let's move back. This should also be comp. Do you want to test that first?
No. That's just
sure?
commit.
You sure? Okay. Let's move this over to 20. This should be 202. 202. Yeah, there we go. And then move one more. No, that's 2 more. And then this needs to go. So let's cycle around 1. This should work because we're not comping. We're not inputting anywhere else.
Okay, right.
Let's test. Input.
Okay.
I think we got it. And then if I input, so let's say we input 2, and then we input 1, it outputs 2, which is bigger.
Okay. I think
Sick,
this change isn't permanent.
Yeah, I think it would re-randomize it every time
Cool,
because
cool,
it's going to be 2 of the instructions we're using in our test.
Oh,
so
yeah.
now, let me go back to the start. Let's run it. Fucking go!
That was
We got it!
That was nice because input was swapped.
Yeah,
so,
that's so it was so easy to find it. Okay, awesome.
We're logged in.
We
logged
did.
in.
That was so awesome. Okay, I'm gonna delete all this. We've done test 1. So now I assume. Yes. So it was showing that was test 0. This is now test 1 because this is the 1 symbol. Yeah. So we've done test 0, maximum 2. Task 1 square root of.
Okay.
Okay, let's delete all of our code. Let's reset all. Let's reset all of our memory.
I'll think about
There's
this.
no quick way to reset memory, so I'll just quickly
Okay, well we only need to check between 0 and 255, so we could just literally square every number and check if it matches. Because we don't.
I don't know about
because
that.
we don't have decimal points, so we can't do like a square root estimation algorithm. So I think we just square loads of numbers.
What a great solution.
Well, so look, simple as best. What can I say? Well, we can build a function. That's what we've got to do. We've got to use a function called like square, and then it will be like much easier to actually pull this off.
Can we? Oh yeah, true. Because like we got the swap command. I think again that's your area of expertise more than mine.
Okay, this is going to be
For building
a bit tricky to figure out, but I believe.
This is gonna be a lot harder, but we just did something which was
Yeah.
awesome. So we just got to do something again. I'm starting to see the Deternary though. I'm starting to get better at this. I like operating. You can tell me what to do, but I like operating this. I'm starting to get it.
Okay. Well, I think the first step we should do is leave that input and the store.
Leave input 1. Oh, but that's not input. Remember, because they're not swapped.
Oh yeah.
So
Change that up. We'll need an input and a store.
Yeah. I think that's low. Oh yeah. So. Yeah. This is me trying to get better at. No, I'm seeing it. I'm seeing it. Yeah. No, I'm seeing the code. Oh, it's like the Matrix.
Oh, in fact, I think we only have to check up to half of 255 anyway.
True.
So.
Okay. Memory reset. Let's get an input on line 1. Input on line 1. We got to input 1 number, and then we got to output our square root floored.
Oh wait, we can do this way simpler. If we divide it by increasing numbers, if it results in the same number,
True.
then
Because how does divide work? Does divide floor?
what does it? I might flip a flag if it's not clean division.
Well, let's see. What's div n?
Round down. Okay.
Okay, sick. So let's say we had like 101. If we divided by 10, we would get 10. So we can check. So let's say we have a loop. We start with dividing by 1. Well, we can start with 2.
We can start with 2. Yeah.
No, but square root of like 2 would round down to 1. So we have
we
have to check 1. Okay, cool.
Wait. Also, this will give us false positives. So let's go with the original.
If we divide 2 by 1, we get 2, even though the square root. Oh fuck.
It's fine. We'll just check every number squared and see if it matches our given number.
Wait, but okay. Let's say I think if we divided, no, that would only be an issue for 2 and 3. So what we do is we say if it's 2, do 1. If it's 3, do 1, and everything else runs our code.
Oh wait, yeah, because will they only give us square?
They will. Well, no. But what I'm saying is we'll only get false positives for 2 and 3. So if we just manually check 2 and 3 and output 1 if it's either of those, then we're good. Because everything else works.
This
because
is so good.
Let's say everything between 4 and 9, everything between 4 and 8 has the square root of 2. If we divide...
Wait, are we checking or are we calculating? What does it want here? Is it giving us square numbers to find the square root of? Input 1 number, square root of n, floor to an integer. No.
It's giving us anything. Example 123.11. See, I've realised an issue, because if, for example, 8, the square root of 8 should be 2. If we divide it by 2, we get 4.
Yeah.
So, this is not going to work. It would only work for the bottom half of the things.
We could try, okay, because there's Heron's method, which is like the approximation of like, basically it's like super simple. You just run in a loop and you find an overestimate, underestimate, method, square root.
Well, if you know that,
I've done it in Python. Like,
you've done it.
The Wikipedia makes it seem way complicated. This is for the triangle.
I just realised we could literally write out everything we're going to do in assembly, do it in LMC, and then just translate it.
I don't think this is possible in LMC.
Okay. Is it possible here?
Probably. Well, they're bigger for decimals. So that's the problem, right?
But the problem, does it require decimals?
Well, we'll see. It might just work because it's an estimation. So you basically it's an iterative method. You repeat this iteration and you get closer and closer to the square root.
I assume X is
you pick a starting number.
So X is our input. Let's say it's 10, which should have a square root of 3. So we start with A as 1.
And you usually pick like halfway, like half of 10, which is like 5, and then it will converge faster, and you can just do like 4 iterations or something.
5 plus 10 over 5 is 7. 7 over 2. And 7 over 2,
it's 3.
Did you actually calculate that? 7 over 2 plus 10 over 7
Oh,
over 2.
plus...
That's what I'm saying.
Wait.
I'm not doing that in my head.
No.
I need a calc for that.
Pull out the calc.
Yeah, I need a calc for that. 5... No. It's... what's that? 3.5. Wait, it went down.
Wait, what do you mean? It's... Yeah, and then...
Oh, I see what you mean.
And then it just gets closer, but...
Okay.
But see, it's 3
If we run it like 5 times...
Yeah, but the problem is, will we lose loads of precision because of the decimal place not existing?
Let's say we went straight to 3. So if we put in 10 and we started with 5...
Wait, let's test this in Python real quick, right? Because we can just convert to an integer.
Let me open PyCharm. Give it a sec.
Different terms and conditions.
Have I never used PyCharm on this PC?
No, you must have.
I think I have. Oh, maybe not with my SSD. I might have had to reinstall it.
Open NOR.
Oh,
you gotta make a new one.
I need Sandbox. I don't have Sandbox on it. Oh.
Selling.
Fine, I'll make a new project for Sandbox. I'll make a new Sandbox project. I did not have I just realised this recording's going to be so boring because none of this is showing on our monitor. It's just going to be us talking because I'm using game capture.
Well, I'll narrate.
Okay.
We're opening a PyCharm project.
Yeah, we're opening a new PyCharm project. I need a new Sandbox project because I did not realise I did not have one. Did I not make it?
Oh, there we go.
Okay.
Awesome source.
Num.
Just make a function called Heron's method and like stack the calls together. That'll do. We can just do a fixed number of iterations.
Yeah. Okay. So we got our number. Def Heron. Heron. I'll just make it A equals. Oh, I'll make it X just because that's what.
Yeah.
A equals X at 2.
Oh no, but we need our starting.
But A is. Don't we start with half of the thing? Isn't that what you said? Because it.
No, but like as in we need our number and our current iteration. Like we need 2 parameters.
Cool. Yep.
Whatever. Just do it in a loop. Just do like for iron range 4 or something.
Okay. I'll do that.
Yeah. Let's not. We don't need to overcomplicate this.
For iron range 4.
Okay,
wait. I'll start with A equals num over 2.
Yes.
Okay. Y equals. Wait. Y equals A. Right.
Yes.
Because then we do.
Yeah.
Okay. Y equals. 2 bracket. Oh wait. I'll just. 0.5 times A plus X A. Oh wait, no, I don't know that. Except num. Okay, Y equals that, and then A equals Y. right?
Whatever. Just put it in, and then
we need to just print y.
yeah.
And then I'll also print sqrt. Oh, wait, is that? That's not a base Python function.
You can just times 0.5.
Print
just y.
No,
num times 0.5.
True. If that works. We'll see. If number 10.
Okay, convert to integer.
My bad.
Nah, that happens to the best of us.
Ah,
Yeah, that's not bad.
that works.
Okay, but now
What if it was- okay,
now
what-
convert to an integer for all of those like things and check
Ooh.
that it actually still gives us like
Let me
3-ish.
very quickly. What's the maximum number? 255. What if it was 248?
Okay, we might need some more iterations.
What if it was 5 iterations? Because to be honest, that's like it's only gonna need more iterations if it's a bigger number. So now, yeah, 5
Cool.
iterations. So yeah. Let's now
Let's do some
let's
do that
now-
integer division.
Wait, no.
there.
Oh yeah. Integer division there. Integer division
There.
and into all this.
Yeah. This is gonna be gnarly. We might need a few more iterations.
What is it? Move to 248. 15!
Oh!
15!
No, but that rounds down. Okay.
Yeah. And then if it was like 57.
Oh, locked in. Okay.
Okay, sick. We just need to translate this to Deternary. Okay. Okay, we're back in the level. Everyone watching at home, we're back. We're done with Python.
We banged out something pretty cool.
We need an input. We got an input. Let's move next.
I don't know where you want to store it. Maybe this is where we start indexing backwards from the end.
Sure.
Because we don't need to see like
this is going to end up pretty long. Oh yeah, true. We don't need to see what we're storing.
Yeah.
Okay. We need to pull up documentation. We need to set, which is 1, 2, 3, 4. That's a set command, and then we just set. But I don't need to do both of these. That's the end of memory.
Yeah.
Do you want me to do that?
Nah, whatever. We can just index backwards. Our program
Because
isn't that
this is slot 26. I don't think we
long. We do not need that many.
And plus, if we do, I literally just go back to this and I update it.
Yeah,
so it's fine. Okay, so we input, we store. Let's input, we store.
Okay, we need to do a loop here.
But we need an initial value, right?
Yeah. We need our initial value. So
Let's get our initial value.
Oh, you do that. I need to.
That's fine. I'll create an initial value right here. Okay. Let me think of how to create an initial value. So it should still be in the accumulator. If we input it and then we store it, it should still be in the accumulator. I hope. So it should still be, and then we just divide, which is 8. Let's divide by 2. Divide by 2. Division by 2, and then we just store that, which is 4, in the one before. Cool. We got initial number. We got a value. Okay. I've made another value which so we input to the accumulator, we store. It should still be in the accumulator, assuming this doesn't work weirdly. So we just keep that, and then what I do is I just divide by 2 our accumulator value, and then store that in the memory address directly before. So we now have an initial number. We have an initial a value. Do we also need an initial y value?
I don't think so, because we immediately calculated it.
Oh, true.
Well, no, wait. This just becomes a. We've got like redundant code here. Why does it not?
Let me confirm that works. Okay. I think that works. 248.
Because a is our estimate.
No, I see what you mean. Okay, cool. We don't need initial y value. Now we need a loop. Okay.
Cool.
Let's
just do the calculation. Hold on, and
then we just jump back.
We just jump back.
Okay.
Wait. But we need to do our count control. So
we need a value of 5, which we subtract every loop, And then when the value is 0, what we can do is we can...
Oh no, we can just compare against... can we not compare against 5? Hold on, what is comp? No, it's comp is address based, fine.
So, but what if we... So we use the Z flag, right? Z flag, if the operation of the accumulator is 0... So this is just... this is an if 0.
Okay, we can do it.
So what we do...
count backwards
So
from
what
5,
we do is we just count backwards from 5. We load our 5 value, we subtract 1, and then we check the Z flag. If it's 0...
Boom.
The
Our loop
output.
is done, yeah.
Yeah, okay, 6. So now we got a Y, we got an A, and now we need a 5. So let's make a 5 value. So we just what we do is we just instant set a value of 5. Can we do that?
I think we just change the we just go to the address and then change the value in that address, and it should
What do you
just
mean, go to-
well, wait, no, let's do a set because when we run the program, it will change. The memory,
okay. What if we load the empty address? No. We need to load 0, and then we need to add 5 and then store it. Right? Like, we can't just instant...
We can just change the value at that memory address to be 5, but it will get, if we modify it, it will get, like...
What?
Wait.
What?
As in, right, we could just go to our 5 variable right now and set it to 5, and then decrease that as the program runs. But then, once the program's finished, the memory address will be 0, and we'll have to reset it next time.
Yeah, but when we're doing the testing, it wouldn't automatically do that.
So I guess we just...
What if we... Okay, if we load the address that's going to be our 5, right now it's 0, so we set it to 5. So we load the 5
we set
value,
it to 5.
we add 5, we reset it, now it's 5.
The
whole program will run, it'll be 0 at the end, and then when we reset, it'll be 0.
Cool.
So what we do is we just load where we're going to
We don't need to load anything, because the accumulator should be 0 anyway.
No, it shouldn't be, because we just...
Oh, right, yeah. Let's load 0 then.
So now we're here, we need to load, we need a 1, 2, 3, we need to load our address, which is going to be 1, 2, 3. That's going to be our 5 value. Is this symbol's our 5 value. We load, and we instant add 5. So we add n for 5. We instant add 1, 2, 3, 4, 5.
Cool, and then that should store 5 in our counter.
And then we load, and then we set. So 1, 2, 3, 4. So we've just loaded it, and then we set it. Yeah, we load 0, add 5, and store it as 5. Awesome.
Cool.
So we got. Let's open.
Hold on, wait.
So we got
we should probably write down what our instructions are, like as we're writing them, so that it's like a little bit easier. Well, I'll just write it down on my paper. As we go.
Okay. Let me format this notepad. Oh, I should really put it up. If I had 3 monitors, it'd be helpful. Because now I got an alt tab between all of this. Okay, so we got. Are you sure we want to do this?
Well, no, as in I was just gonna write down where everything is. Yeah.
Do you want to write it down? Because
I'll write it down.
Do you want to do it? Okay, because I think I know what we're doing.
Okay, so that's input.
We got input. We got let me just check. So that should be load. I mean set. That's set 27.
Which is
No, set 26. Because it goes 0 to 26.
Yeah, so
we're setting memory value 26 to our input.
So that's the number variable. We've got number initial counter. Cool.
Then we div 2, which rounds down, and then we set in 25. So in 25.
Oh yeah, not initial estimate.
So A is in 25. And then once we've done that, we then load.
Start our loop.
We
yeah,
load. We load 24.
No, wait, yeah.
This is not loop yet. This is still set up. We load 24. Load 24. We add 5. Instant add 5, which is add n. So add n 5, which is this. The add n 5, and then we set 24. So we load 24, which is 0. We set it. We add 5 to it, and then we set it. 0.
Cool.
Yes, that's Let me just check there's no instant set, because this is U set, but that's not instant. That's indirect set, right? Instead of
loading data from where they put the
Wait,
accumulator.
but is that not the exact same? Which is. No, I think this is just written weirdly. I think this is indirect set.
Yeah.
This is indirect set. It's fine. We'll probably need our indirects for later tasks when they get more complicated. We don't need it right now. Okay, but that's everything.
That's what we've got, yeah.
So that's all initial setup. Now we need a loop. Okay. So this is when it says 5. So now we where do we start?
Okay, hold on. Let's put a none instruction first, just for clarity, so we can see where the loop starts.
Oh yeah, true. I'll just move over.
we'll just
No, that's good.
That's our none.
And then so now we need to start the loop.
I think we might need a couple of temporary variables.
We start.
Yeah.
Well, everything should be.
Oh no! Wait, yeah. We can just. Okay.
So we just do num div a. So we load num. Let's load num right now.
Yeah.
Let's 1 2 3. Let's load num, which is in
26.
26. Yeah. Which is the same place we set it. Yeah, that's correct. We load num. We then div. We div n 1 2 3 4 5 6 7 8. We div n by a.
So we use div.
No. We just need indirect div.
Yeah,
right?
we just need indirect div. So I think it's just called div.
Divide the accumulator by the value of the address.
Yeah,
so we go to 25. So if we div 25, it goes to 25, finds our a value and divides. Sick. Okay. We use an indirect. Nice. We're so talented.
We're so cool.
We're so awesome by using indirects. Okay. Then, so we've done that step. We've done the innermost bracket. We've loaded number. We've divided it by a.
Now we've got to add
a. Okay. So now we need to load. No, we don't need to load a. We need to indirect add. Yes.
Oh yeah.
So we indirect add, which is 11, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We indirect add in 25. Mm-hmm. We add the value in 25 in the accumulator. Then we need to half all of that. So now we just div 2, which we can instant div.
Yeah, div n.
Div n 2. I'll move over one more. 1, 2, 3, 4, 5, 6, 7, 8. Div n 2.
Mm-hmm. Now we do our loop.
Wait, I think I made a mistake here, because I think that is meant to be an indirect div, but that's an instant div. That's an immediate div. That's meant to be an indirect div.
Switch that out.
Yeah. That should be 14. That should be that.
Cool.
Because that should be indirect div. But that needs to be direct div. Yes, that seems correct to me. I'm glad I called that.
Okay, and now we just do our count control for our loop.
Yeah.
No, wait. We need to store it. We need to store it.
Do we? We need to store in A. Store in A. Okay. So now we set. Now we instant set, because we have our current value. We instant set, which is 1, 2, 3, 4. Instant set that in 25.
25. Yeah,
that is 25. Down. That is A. Yep. And then we move over one more. Let's count control time. We need to now load our 5 value. You know what? I'll leave another none.
Yeah, leave another.
I'll leave another none. Okay. Now we need to load our count control, which is instant load count control, which should be 24, which is that one. Yeah, that's count control. We instant load. We instant subtract 3, 4, 5, 6. We instant subtract 1, and we load. And we set. Oh no! Now before we set, let's do our jump Z, which is if the Z flag is 0. Oh no! Yeah, we've just subtracted. We've just subtracted 1, and now if it's 0.
Oh, then we jump past it. Otherwise, we do the.
So now.
Well, how much space do we need to leave?
Let's leave like 2 lines, because we can leave a num command if we have to. Now when you jump Z. 10, jump Z to past there. So S is right there. Let's leave.
Do 4, I think.
Well, if I move down a little bit, you can see exactly where we're jumping now. We're jumping all the way down here, which we do not have to do, to be honest.
Wait, if you scroll up, does it? Yes.
It does. It's very cool. I saw this earlier. Yeah. I think we can go back like just to like here.
Well, because we need to set and then break always. So yeah, that works.
Okay, cool. And now, if that does not succeed, we need to now store it. So we need instant set. Instant set 1, 2, 3, 4. In 20. Yep, that's
in our counter 24.
And now we need to jump always back to the start. Right.
Yeah.
Now we jump always, which is 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Jump always.
Let's jump to the none, I think.
Let's jump to the I was going to say something. Yeah. Jump always to the none. First none. Yep. And now.
Okay, and now this is where we
can move
start
over,
end.
Which is we jumped here, which now this is the end, and now we load A and we output.
Okay.
Instant load. Oh, then finding which things are switched here might be really annoying.
Oh god. Oh no!
That's such an annoying mechanic, but I'm actually glad it exists because it's really cool. But it's gonna suck, and we're only on test 2.
Input please, input please.
Input please. So now we have just this is an instant load of 24. No, that's our counter. 25. That's our
initial estimates are 25.
That's our 25.
Yeah.
We've just loaded estimate, and now we just out.
Yep.
Which is 2.
And then hold.
And then we hold, which is back.
Cool.
Let's try it. Okay, let's go back to the start. Let's back to the start. We have to do this every time. Back to the start. And now, do you want to just run in testing mode? It's
let's do it. Let's do it.
Oh, this is gonna take so fucking long. This is speed up, by the way. This is speed up.
Oh no.
We've been doing this for half an hour. Oh no.
Oh yes! Yes!
Let's fucking go! Okay, we did it. Okay, now
we goated or what?
Now we just need to run it 4 more times.
Oh my god.
I know why they do it. It's because it's to make sure we're not just if input value then output.
Yeah, because.
But it's just this takes a sec. Okay.
Oh.
We did it. We did a square root in geometry computer. Let's go.
Oh.
Okay. Sick.
See, I got ball knowledge when it comes to.
You do. Yeah. Honestly, I would not be able to do this without you. I think I'm contributing though.
No. You're the programming. I can do that. No. Okay. Wait. Did you catch what the input was?
What do you mean?
Like, did you see what the input was so we could see what the output was and see?
Oh no, I didn't. Sorry, but yeah. This is start. This is disable test mode. That resets the test. Okay, let's remember that. It's good thing to keep track of. My bad. Because I need to go back with this.
Maybe we could chop off an iteration.
Yeah. I mean, but remember, 5 iterations works for everything.
That's
4
true.
iterations works if it's below like 200, which they're probably testing with 255, which is the max value, because they're probably doing both range, some random values.
Good testing data. What?
Mm-hmm. But now we know, and we're not going to do that for like test 5, which is going to be like so fucking long. Well,
yeah.
that guy in the video was running his test 4 test for like half an hour of the video or something. No, not half an hour. There's someone who's beaten this level in 16 minutes, so it can't be that long. But
yeah, well, there'll be a hard-coded because you can do estimation, they have those crazy quadratic estimation algorithms, and you could just basically plug in one of those formulas and get. Actually, can you do raising to the power here? Not really.
Could you?
Well, yeah, you could do squared, cubed, but
oh my God,
not in a.
I just realised how long resetting all this is going to take.
It's fine. We'll just change it as we go.
Okay, cool. Now we need to find out what's swapped. I will disable testing mode. Yeah, keeps it.
Right.
Okay, and let's go back to the start and let's run it.
Okay.
Okay, let's find the square root. Oh shit! It's not input. Input has not been swapped.
No. Wait. Let's start with.
What's the square root of 3? No, 4.
4.
Because that should be
I like
2,
that,
which
yeah.
is that.
Right, 4. No,
But the thing is, it's not gonna work. So something after this input is gonna be incorrect, and we're not gonna know. Oh! There was a jump command in there. Sorry, I did a sea lion noise. I did the sea lion.
Okay,
cool.
wait. Is that what?
Let's see where it jumps. Look at it, see where it jumps.
What?
Is that halt?
It might be.
Is that halt?
I was praying for halt. I was actually praying for halt.
That might be halt, but I thought it jumped last time.
Wait. Change that to halt.
True.
Change that to.
Yeah, I know what you mean.
Yeah.
So this is input. That's halt. And now we can see if halt's been swapped. It's been swapped.
Okay. What?
To this. This is halt. This is whatever this was. What was that? It is
1, 2, 3, 4, 5.
It's the. Oh wait.
2, 3, 4, 5. It's load.
It's load. Load has been changed to halt.
Okay, wait. Change that back to input before we do anything.
Oh, what did I do? Yeah, no, that's fine. Yeah, this is input. Now, this is load. Normal, so instant load is halt. So now if I change this to halt.
Alright. And then
let me look. This is also instant.
We've got a load after our none.
Yep, yeah. After the none is a load, which I'm changing right now to a halt.
And then we've got another load after the other none.
Yep, I see it. Bang.
And then we need to change our halt. Oh wait, no, we've got another one after another none.
Yeah. Thank God it's halt. Holy shit.
Yeah.
Okay. And then this should be now instant load.
Awesome.
Let's see if this works. Well, we can just run in testing mode.
Yeah.
We can just run in testing mode because it doesn't reset if it's wrong. So just go.
Speed that up.
Seems to be working so far.
Yo,
yep,
come on,
I think it works. And it's looping. I think we got it. Thank God it was halt. Thank God it was halt.
Oh. Wait. Is it hard coded or are we just like so lucky? Oh.
Test 0 and 1 done. Okay, what's next? Greatest common divisor. Ooh.
Oh, okay, wait. We can use what is it? Euclid's algorithm for this. You know, we did this in assembly. We have actually done this in assembly.
I know we have, but this isn't assembly. Euclid's algorithm. I know you told me how to do this. Algorithm. Efficient? Yeah, fine. Last. So Wikipedia. Okay.
Wait, scroll down. There will be an example.
Description procedure. Oh my God.
Oh, this is so long.
Don't
go on Wikipedia for just search up. Just search up Python example.
Wait.
Okay.
807 41 because 807 is 41. That's 327.
So you find the difference.
Oh yeah, you find the difference, and then you check the bottom number. Oh, and then you find the difference between the lower number and the difference, and then you find the difference between the first difference and second difference. But times 2.
Because that's the different. I guess because 150. Wait. Sure.
Cut but not dull. Okay. That is pretty simple. If n equals m times s. Then any divisor is m. Okay. Oh, I see. I think. Your press is not set to run Java applets.
Okay, so there's an interactive example, but I guess we can't run it. Oh no. Right, let's mock this up in Python real quick.
Yeah. Let's open PyCharm. Let's delete this. We got this. Let me check testing mode's off. Testing mode's off. Do you want to pull up your laptop? Do you have your laptop? I can pull up my laptop.
Pull up your laptop.
Yeah, because I'll reset this and you can write in Python.
Okay. Sounds good.
This is so fun. Oh, it's not much, is it? Oh no, it's working.
Oh,
It's on.
yo, he's alive
It's alive.
somehow.
Well, while that's running, how about you start thinking about this and I will reset our code.
Cool.
Oh wait, these are where we stored values. Yeah. Let me reset the stored values.
Oh.
Yeah. It's the broken. Okay, I'm just. Oh god, this is gonna take so long.
Oh. Okay. What are the other challenges, by the way? Because
Oh yeah. Okay. Let me pull it up.
Square root and greatest common divisor.
Greatest common divisor, ternary representation.
Oh, okay, that's
input
fine.
one number,
That's
output
fine.
7 numbers, the lower 7 trits of n's ternary representation. So 377 is 0111222. Okay, that doesn't seem too bad. I think we do that. And then the final one is next prime.
Okay, that's fine. We'll just
Input
make
one
a division
number.
function.
Smallest prime number that's bigger than or same as n.
Wait, what's the range for n?
100 to 1,000.
Oh. Okay, we can
you know what?
force it.
I'm going to the toilet.
Okay, what's your code here?
It's the
That's
on recording now. Oh, I'm 98%. How is this alive? I haven't used this in.
Your computer is.
I have a sandbox.
different.
I have a sandbox project. So you can open and delete whatever it's called. You know how to use Python, right?
Yeah, I'm totally not going to steal an algorithm of W3 schools. I see. This may be more non-trivial than I thought because we'll have to basically. It's not going to be too complicated, but we essentially do a modulus. So we divide the number and then we've got to find the remainder. So it's going to be kind of.
Yeah, that's not nice.
Effort.
Oh, we got it though. I'm just. Well, I need to go back and manually reset all of our codes, so
Okay.
that's gonna take a sec. So you got time to figure out whatever you're
Right.
doing.
Let's try 117. Let's see if this works.
Ugh.
10. Okay.
So what a code to reset. wish there was a reset code button. Imagine there is a reset code button and I just don't know about
I
it.
just haven't seen it.
You know what? I don't mind. It adds to the experience. Like, we're literally coding assembly language directly in ternary within geometry dash. So
It's honestly crazy.
yeah, this level's insane. This is so fun. I mean, we're literally just coding. I haven't coded in like a sec, so.
Bit of a brain workout.
Mhm. It's good. I need it. Okay, I'm actually almost done.
Cool.
I always reset stuff the wrong way. I'm starting to be able to read the character set a bit better though. Yeah.
What other numbers can I test?
Oh, by the way, if you want to stay for dinner, you can. I don't know if you're able to, but in case you want to.
Nah.
Yeah, it's fine.
My my uncle's around.
Oh, yeah. Cool. Okay, I'll reset code.
Okay,
So,
I have a draft.
Okay.
Right. We can get rid of this modulus operator and replace it with some subtraction and addition, I think.
Well, b is larger than 0. T equals b.
So our temporary.
Yeah, so you swap them. I see.
You see the
No, you
mission?
make it temp.
Yeah.
Oh, I didn't. That's nice. I didn't make it. Okay. So while wait, what did you? We can do that.
It's fine, no, because we will be doing exactly the same as the
that's
4,
zero.
except the count is controlled by
Temp
the...
b equals a modulus b. That's division maker, right?
Yes, so it's
A-
fine because we divide it by...
So that's the difference.
Yeah, between...
Oh, no, I see what you mean. If we just did remainder, would it still work?
What do you mean?
Like if it wasn't modulus, if it was just remainder, actually that wouldn't work. Because I mean, like just difference. Sorry, not remainder.
I think so.
Because that would be a lot easier to make. I don't know.
Because I saw the difference. Hold on, let me pull up the Wikipedia again.
Yeah. Maybe it's
Because like these
have to find
diagrams,
out
they
which one
all show difference, right?
Yeah.
Wait, this one, right? Yeah. This is what I was thinking about.
maybe modulus just speeds it up.
Wouldn't these? Right, because
Like I figure modulus just makes it faster, but I figure it's not necessary.
yeah, because
Is difference even that much easier? Because the problem is you can get underflow, and we're trying to work it out on that.
why don't we just calculate the modulus?
Okay, how do we do modulus?
What is
The thing is when you
modulus?
divide it rounds. When you divide it rounds.
Ooh.
Oh, you divide, then you count back up. So you divide. So let's say you got 10 and 3. You use 10 divided by 3, and you get 3. Then you do 3. Is 3 smaller than 10? So you add another 3. 6 is smaller than 10. Add another 3. 9 is smaller than 10. Add another 3. 12 is now bigger than 10. So then you have, so 9 is the last one. You 10 minus 9, you get 1.
We get, hold on.
I think that's the easiest way to do that.
Modulus,
Assembly language.
ASM.
I think I've done modulus in assembly, and that was how I did it. There might be a faster way.
Stack Overflow, come on. It will just be, it will be either incredibly complicated or...
It is a known constant, but we don't make it rough. We should write it fast.
Okay, well, thank you for using... Wait. Okay, so, in x86 we just keep giving you modulus.
Well,
Okay.
you just want to do my method.
Yeah, let's do your method.
Okay, well let's do everything else first, because it's in the loop, so we'll just manually have it in a loop.
Yeah.
So we need 2 inputs. Yeah, input 2 numbers. I'll get 2 inputs up.
Right.
That's one input. On one input we need to store it.
Hold on, actually I can use it out of this.
Let's set it. You know what? I will actually I will set at 728 this time because I figure we're going to be writing more than 27 lines.
Yeah. Okay.
This one seems long. Okay. 1, 2, 3, 4. Let's set our input in the final address. Oh, are you gonna write this on? Are you writing a notepad?
Yeah.
So we got an input, and then we got set 728.
And then at 728 we've got, what should I call it? I'll just call it A. That's it.
And then
we need it again.
And then we need a second input, right?
Yeah.
So we just go straight input, and then we need a set in 727.
B.
Okay. We got
Right.
two. We got 2 inputs. What's next in the code?
We have to create our
Wait,
for
I
loop.
can't see it. Oh yeah, now we need our while.
I'll just come back.
So while the second one, which we've just inputted. Okay, well, so if we're starting the loop here, I'll add
We
none,
put a no op, yeah.
and then I'll load 1, 2, 3. I'm gonna load the one we just inputted. I'm
Yeah.
gonna load B from 727. So I'm loading 727.
Mm-hmm.
Then, if it's 0.
Yep.
If it's 0, we can do jump Z because the Z flag will be 0.
Oh, wait, no, but it won't be 0.
No, it will be 0. Let me check. Z flag. If the operation. Oh,
Yeah.
arithmetic.
So wait, why don't we just subtract 0?
Yeah, I was gonna say why don't we just add or subtract 0?
Awesome sauce.
Yeah. I don't know if you need to do that, but it's good to do it. Let's just add 0. It's a lower command. 2, 4, 5.
Cool.
I'm gonna add 0. I don't know if this is necessary. Might be a waste.
Whatever.
It's fine. Now, if B is 0, Z flag will be 0. So we're gonna jump, which is 16. You know what? So wait, this is 9, right? Because it's 2. It's 100. 100 should be.
Yeah, 9.
100 should be 9. Wait, let me.
139.
Because that'll make it a lot faster to read. Yep. No, that's subtract, and then jump is 3. I need to make it faster for me to be able to read ternary because I'm not used to it. And then jump Z to I don't fucking
Let's
know.
put a pin in that.
Let's leave it for now. I'll leave it at 0. So that's line 1, 2, 3. No, line 0, 1, 2, 3, 4, 5, 6, 7. Line 7. We need to go back to.
Yep.
That's our jump Z, so that would be our ending. Then, next line, what are we doing next? Because we got our while.
Right, we need a new temporary variable.
We need okay.
New temporary variable.
So now we need to load. We need to load B.
Yeah, we need to load B
Load
into
B.
our new temporary variable.
But we've already got B loaded. We've already got B
No,
loaded.
but we won't at the end of the loop.
No, but we're at the start of the loop.
No, but as in once the loop finishes and we start again, B won't be loaded. It will be.
No, but we've just loaded B. So the loop starts here.
Yeah.
We load B.
Oh right, to
0,
check the condition. Yeah.
And
yeah,
if it's
yeah.
not 0, we still have B loaded.
Fine. Let's load that into temp. Then.
So set that.
726.
We need to set that into temp.
Yeah.
1, 2, 3, 4. Set that into temp, which will be 726. 1, 2, 3. That is 726.
Alright, and now we need to do our modulus. So B is going to be equal to A mod B.
Okay, modulus time. We've got B loaded. Well, no, we've got temp loaded, but temp is B. So it's the same thing. So we do B mod A, right?
No, we need to do A mod B.
A mod B. So we need to load A. Load A. Wait. Load A. Take away B until we get an underflow.
Yes, and then
reset.
No, but wait. Does it?
Oh,
We can't do negative numbers.
No, I know, but that's why we
Yeah.
subtract. But we comp every time. We comp, and if we don't underflow, then we subtract. And then we comp if we do.
And then we do.
Then we don't subtract. We've got
I
our
like
underflow.
it. I like it.
So then the value we have is the modulus.
And then we just put that directly into B.
We need a second. We need a loop within a loop. We got a loop within a loop. We got a
loop action.
O squared. Okay, sick. I'm gonna add another none because this is our loop within a loop.
Yeah.
We got a loop within a loop.
Wait. Hold on. Can I set line numbers on here? That'd be brilliant.
So I'm loading. Ooh, I might need another temp.
Yeah, that's fine.
So I'm gonna load A. Wait, before we start the loop, I'm gonna load A and I'm gonna set temp 2 in 725, and then I'm just gonna load that every time because that's the one I'm gonna subtract.
Yeah, sounds
okay,
good.
Cool.
So
wait,
you put the none.
Do we need A, like the original A? Probably. Yeah, it's fine.
No, because we reassign it at the end of the loop anyway.
To temp.
Yeah, which we had our first temp, so we actually don't need A.
Okay.
Because A gets reassigned, so fine.
Okay, I'll just edit A. Sure. Okay, so at the start of the second loop of the inside loop, I will load A, which is in 728, which is the final address.
Yep.
That's in final address. So I've loaded that, and then we need to subtract B. Oh no, we need a comp B.
Comp B, yeah.
I saw the comp instruction. I was like, that's so useless. Why we're never gonna use that. And now we're using it. We use
crazy,
it every time.
like holy instruction set. By
I
the way.
know. This instruction set is so sick.
This
Creator of this level, if you are somehow watching this video, you are so awesome. We love you.
Yeah, like LMC is nothing. Like indirect, direct, comp. Oh,
this is so
beautiful.
Sick. Okay,
right.
So we're comping. We need to subtract. So it's the address, which is 727.
Yeah,
right?
for B.
Yeah, 727. So we're comping B, which sets flags. So now we need to jump to we need to again set a jump that we don't know where we're jumping to because we need to jump out of this loop.
So jump, what is it? Jump OF?
It would be
UF, jump UF.
No, it wouldn't be. It wouldn't. Yeah. Sorry. Remember. So yeah. So the next
jump
line,
UF.
we need to have a jump UF.
Yeah, I don't know what to do.
Yeah, that's another TBC load destination. So again, I'll leave it blank. Yeah, I see the other one we've left blank. In line 7. This is line not 7.
Whatever, we can find it.
Yeah. But if we have not gotten underflow, then we need to actually subtract. But we need to do an indirect. No.
We could do a direct
sub.
Wait, what are we subtracting? We're subtracting
this
B.
This is instant sub. This is no. We need direct sub. We need direct sub, which is 12.
And it's 727.
We're direct subbing 727.
And then we need to store that again.
And then we loop. We need to store that? Yeah, we need to store that in A.
Wait. We don't need to store and then load again because.
What do you mean?
Oh yeah, we do.
I'm saying we've loaded A, we've comped B and checked, then we subtract B and restore in A.
We don't need to do that because.
What do you mean?
We can we don't need to keep looping. We store in A and then we load in A. So it will remain in the accumulator. We can just move the load above. Whatever, it's too late.
It's fine.
Yeah.
We've done it, and besides removing a line, it's so
that's long.
difficult.
So let's.
Let's just store.
What's planning?
Yeah. Who cares about fucking planning? Instant set into A. 2, 3, 4.
7 to 8.
Let me just check that we got a loop in a loop. This is instant loading A. This is instant loading A. Yep, instant set a current value, which is new A, into 7 to 8.
Awesome.
And then we need to jump back up. We need to always jump, which is 15. We need to always jump. We need to always jump back up to.
I don't know what line that is, but
first none, which is the hat symbol, which is 10. No, it's not. It's not 10. It's 9. I was close. It's 10 if you have 0 to 1.
Can I? Is there an option to show line numbers on?
On Windows 11 Notepad, I'm not.
Because that would be goated.
That would be very helpful. Look it up. Can you show?
Oh wait, I forgot I have the internet.
Yeah. We've moved on from paper to laptop. It's like we're like going through like the ages of humanity.
Oh yeah.
Okay.
We use the computer to make the computer.
I believe we have now finished the loop within a loop. So now I'll leave another none line, and this I believe now is where we're jumping to once the comp updates the flags. Once we get an underflow, we need to jump here.
Oh, I see. It tells me what line I'm at the bottom.
Which I'm going to just set to an input. I'm going to go back to our...
Okay, wait, back it up. Back
Okay,
it up.
I'll wait.
I just got to the jump, and we're jumping to line 9.
Back to line 9, yeah.
Cool.
You're going to look up the line numbers thing.
It just shows you at the bottom, right there.
Oh, okay, cool.
So you gotta click it.
And
then
now we're here.
Now we need to do our jumper thing.
This is the end of a loop within a loop. Jumper.
Okay, do we put
This is where we're jumping to at the end of a loop within a loop. So
we is that another none?
I've left it. I've left it.
Yeah,
I've just put input in here just so I remember. Then this is our this is the jump UF. Yeah, this is the jump UF, and we need to be jumping UF to S, which is there. So we're jumping to this line.
Sounds good.
So we're jumping. So if the comp underflows, then our value is the mod. So we're jumping here.
Right, and that's in the accumulator.
So
we then store that into B.
So now we have it in the accumulator. So we instant set. So because we set B to temp, so now we need a instant set B, which is 727, with the value in the accumulator.
Yep.
And then we go with one more. I'll spell a bit extra. Now we need to load A and set it.
We need to load temp and set it to
A. So now we instant load
726.
726.
And then set. Is there a move instruction?
Yes. No. Swap us with the stack. Oh, we're not using the stack.
Whatever. The stack is not.
We can use the stack later if we need to, which I hope we don't need to.
I prefer the hard-coded variables.
I agree.
This is quite.
So now we've loaded temp.
And then we set it to. Wait.
Load. Because we need to set A to temp, right?
Yes.
We set A to temp.
So
now we've loaded temp and we set A to accumulator.
Yes, which is 728.
And now we set A.
So which is 728.
Oh wait. Yeah, because we have an accumulator, which is 728. Oh no, yeah. Set A to accumulator. Awesome. And now we need to jump back up all the way to the start of this loop, which is ages ago. So now, we need to jump all ways because we broke
line 5.
We broke the loop earlier, so we jump all ways
to line 5.
To line 5. Let me confirm that. Where's our first non-instruction? I'm all the way at the top. Yeah, but I'm gonna go one back. I'm gonna go to because 0, 1, 2, 3, 4. Because your lines start from 1.
Oh yeah,
but our lines here start from 0. So I'm gonna jump back actually to line 4 because that's the none. That's just standardization.
Yep, that's what I was pointing.
Yeah. Bang.
Okay. Now, wait, while you're there, you can change the old jump.
Oh, true. Well, first, we're here, F. This is where we're continuing after the full loop. I'll set an input here. I've left another none.
Yep. That's good.
So now I need to go all the way back to the first jump, which is line
7.
Well, line 7, assuming we're starting from 0. So there's line 8 there, line 7 here.
It's not line 8 here. This is line 7.
Oh, okay. So wait. Let's confirm this. So we got an input.
Yep.
Set.
Yep.
Input.
Yep.
Set.
Yep.
None.
Yep. Add 0.
Add 0.
Yep.
No. This is not add 0.
What is that?
That's loading A. We load B. Sorry.
I forgot.
Is while B is above 0.
Yeah.
So we need to load B. Then okay, cool. We've sorted that out. Okay. Line 7. There, line 8. We need to go to F. Yeah, F. Which is all. Oh wait, no, we're not. That's just for standardization. It'll make me feel better. To the trident thing. Which is our none line. Okay, we got none line, and now here. This is where we're starting the next section of the code, which is just the output, right?
Yeah, we just need to output A. So we
load A.
And then out.
I think that works. Yeah, load A.
Which is 7 to 8.
Out. Yeah. Output. Halt.
Oh,
You wanna
almost
try
got
it?
the hole. Yeah. Just do it in the testing.
Yeah, I'll just do it in test mode because we don't need an input. They'll say if it works or not.
Yes. I have a feeling we've got an incorrect jump somewhere.
They already stopped it.
That is
What
that.
command is that?
What is
That's a store. Wait, that's a halt. What? How the hell did I do that?
Oh, it looks like a 9. It looks like a 9. Look, see.
Yeah.
I don't know.
Okay, well. Oh no, I started from the wrong place. Okay. I'm in speed up.
Yeah,
Okay.
sounds good.
We gotta wait a little. Do you want to sample it?
Oh, yeah.
This is ON squared, and I gotta hold this the whole time.
Absolutely beautiful.
Yep. Cool.
Maybe we should use small numbers and tested it ourselves.
Nah, but if it works, then we just keep going. So.
Yeah, we've saved time. But I have a feeling we might have an incorrect jump or something. Oh,
Let's go!
no, we got it.
Actually,
We
so
go to
cool.
the source.
Okay, we just gotta do that 4 more times, and then we gotta find the swapped command.
Oh god.
You know, while this is running, I'm gonna tab out and close our extra tabs that we don't need.
Yeah.
Speaking of again. And it'll open. Oh, I was gonna actually, before we did this, go out to the co-op and grab some snacks.
Bit late now.
Yeah, it's a bit late now. Unless
We could leave it running.
True.
Well, let's finish this first.
Yeah. Well, let's finish this, and then we can literally just leave the recording running, go get some snacks, and
Yeah.
come back in 5 minutes.
Sounds good.
Definitely good speedrun time. It's working.
Yes.
Okay, well, this is task 2, but that's the 3rd of 5 tasks.
Oh, okay.
Well, we need to finish it off first. We need to get the what's it called?
We're gonna need the modulus method again for the next task, I
That's
think.
fine. I mean, we got it working.
We got it down.
What's the next task again? I'll actually tab into that right now. It was the
I
it was
think
the 7. It was the 7-digit representation.
Yeah.
Oh, it was just a word modification. Oh, I was the only one who did the word yesterday.
Oh, I forgot.
Clearly.
I was tired.
That's
I was like, oh, I got to do Wordle. And then I forgot about it. And then never did it.
Yeah, ternary representation and then next prime.
Oh. Okay, there are methods to find if a number is, to test if a number is prime in O of, I think it's O of 1. But it will only tell you if the number is, not prime. Or something, 80% of the time. I don't know.
This is 4 tests. I'm gonna. Yep. Okay. Go. Okay. Just run it. No. I'll run it outside. I'll run it in debug because then we have to input. So okay. Is input working? Has input been swapped? No.
Oh, what?
Ugh.
Okay, right. Let's try.
I'll just reset these.
Let's do 2 and 4.
You want to input 2? Cool. I will input 2. No wait, no, I got it. So now it should have been stored. I can actually check if it's been stored. No, I can't check if it's been stored. That should be 4. Yeah, that's 4. Alright, we'll continue to run it.
Yep,
2
and then
4.
we should have set that, and then it should.
Oh, we got a random jump in there. Yeah. I
Okay.
saw that. It got to, I believe.
We should take a video.
I believe it got to that.
Oh, okay, yeah.
Wait, let's. I'll run it literally from here. Yep. I don't know if that's a jump always,
Well,
or if it's just.
there are no flags.
There are no flags, but the thing is, it could be a flag if 0.
Oh, right.
So, because I don't really want to delete all of our code just to
We'll
test.
put a jump. We can just put a jump always in the first thing and see if it jumps to the.
Oh, true. So let's take our input and let's change it to a 15. So
Oh
jump.
no!
always.
Please tell me it's not like a jump. 2 jumps have been swapped with each other.
Well, the symbol that's been swapped is oh god, that is a jump. Jump if the Z flag is 0, but it's jumping to the wrong. Yeah, it's jump if the Z flag is 0, which it's not, but it's still jumping. So I think it might be jump always has been swapped with jump if Z is 0. But the problem is this is still going to jump if that's the case. So instead...
Wait, we could just gamble, maybe.
Well.
No.
Well. You know what? Instead, what if we make the Z flag... So, okay. It's gotta be... This has either been swapped with this or this. But if we test this...
Oh, wait. If we change the address, maybe. Decrement it by 1.
What do you mean, like, change the address?
Well, because instruction point will jump to this address. If you change the whatever's stored in there, because you change the address.
No, but it still does.
Right.
But what I'm saying is, if instead of changing the first line, we change the second line to jump if Z flag is 1 and set the Z flag to 0. Oh no, because currently Z flag is 0.
Yeah.
And now let's do a jump NZ. So now, if this does jump,
that will be.
We know
just
what
loop
we
to itself
know.
Constantly.
I know, but I see. Well, then we know what's been swapped. I'll just make it jump like someone.
Yeah.
If this jumps, we know what's been swapped.
No. Okay.
No, that's fine because then we know jump always has been swapped. We know jump always has been swapped. So what has happened is, I believe, jump always has been swapped with jump if the Z flag is 0, which that would have been fucked up to catch. So we need to just swap 15 and 16 around.
Okay.
Okay. So this is the first time it comes up. So in this line, I believe you'll find our first jump. This is jump Z
in line
7, 8, which is line 8
Yeah.
for you, but it's line 7 for me. This is a jump Z currently. I will change it to a jump always.
Cool.
You can indicate that line's been swapped in your notepad if you want. Then our next jump
is line 16 for me.
I see it. Which is this. Yeah. That is line 15 for me. This is a jump always, which I will change to a jump Z. There we go. Now, let's keep going. When's your next jump?
Line 21.
Yep, I got that. This is a jump always. Let's change it to a jump Z. And now...
That's it, looks like.
That's it. Well, let's see if it works.
If it doesn't, ooh.
I hope this works.
Okay, well, no, the program flow is going well.
No, it's not.
Okay,
Well, where did it jump?
Okay, let's...
So it did always jump.
The commands... Yeah, even though we've changed that jump...
Oh my god,
is that actually a jump command?
You know what?
What?
Yes. I think I fucked up. I don't think the jump commands got swapped. I think one of the addition subtraction commands got swapped, which didn't change the Z flag, which meant the jump always triggered. I'm going to go back and I'm going to change all the jump commands back.
Cool.
Okay, so this is a jump Z. This should be a jump always.
Yep.
This is a jump Z. This should be a jump always.
Mhm.
This is a jump always. This should be a jump Z. That's it.
Cool.
This is what our program was before.
Right.
So, I think...
What line is the... It's that
so
one,
yeah,
right?
yeah. This, so if I go here, this is where the Z should not...
That's our first jump Z,
Yeah.
right? Maybe
So,
it's the add command.
Yes, I think the add command has been swapped with something. But you know what? We don't need an add command. If I just
turn
change
it to a no op.
No, I'll just change it to a subtract.
Oh, wait, yeah.
And then... Oh, shit.
No, but it didn't jump. No.
That's...
No.
This is very strange.
Because
So,
jump if it's 0.
maybe the load's been changed. Okay.
Yeah.
What I'll do.
Wait, can we...
let's check our set commands. So I'll go back to the start. What I'll do is I'll make these first 4 commands run. So our 2 inputs get set, and then I will stop the program. I will check the addresses.
Yeah.
Wait, no, we would literally have to sit here for like 5
Can you
minutes.
not? Oh.
But I can change the addresses.
No, because they'll mangle our program.
Yeah,
if
but
you
I'm
change
saying
it too low.
I'll change them low, but not within the program,
Okay.
and then I will go there and check them. But I'll stop the program before anything goes wrong.
Cool.
So what I'll do is I'll change this set to be in 2.0, which is past our program.
Wait, but even if the sets were broken, right, it would still not be 0. Because no, if our load command was, what would load have to be in order to that would be 0?
It would just have to not load. Because
no, what we've got in our accumulator is, well, I don't know what the second number is, but it's definitely not 0.
How about 2.4, and then what's it doing? So it's I'm doing 2 and 4. There's a none. It's doing this, which is loading the 5. Oh, it's loading 0, and then it should be adding 5. Is it not adding 5? It's loading 0, and then it should be adding 5. But I think, oh no, it might be the add command that's off, because then it wouldn't be adding 5, it would still be 0.
Oh, yeah, I see what you mean.
Oh, that's gonna be so fucking annoying to find though.
Wait.
If it's not adding 5,
replace the load with a no op, and then it should
replace the load with a no.
Yeah, and then it shouldn't jump. Try that, and then that will tell us for certain if it's load that's broken, and then we can work from there.
I know what you mean. But the thing is, even if add is not broken, it'll still not jump, because it will not be 0 either way. What I'm saying is, so let's say we input 2 and 4,
yeah,
and then we don't load anything, and it adds 0. It'll not jump either way, assuming the jump command isn't broken. I guess it could test the jump command. You want to do it?
Yeah. See what happens.
Okay, I will change this load to no operation.
You only need to change the data.
Huh?
You can just leave the command as no op. Whoops. That's what I meant. That's what I was like, change it to that.
Yeah, no, I see what you mean.
Yeah.
That should be the correct address, though. Let me change this back to 0. I'll input 2.
Yeah. And then 4 or whatever.
4. It's not jumping.
Okay, so it's not the jump command that's
Oh,
broken.
whoa, I saw a jump.
Yeah. Okay, so
Wait. I believe this line is jumping. But that's a normal jump. That's a jump UF.
Okay, do you know what?
A jump UF is jumping when... No, I think it's correctly jumping. A jump UF is correct.
It has to be load that's broken. But what would it... Wait, I'm so confused. How would this even...
I just realized it's always gonna... It's gonna run forever.
Yeah.
Is anything else even... None of the jumps are broken.
No.
It's gotta be the add that's broken.
It has to be. What other commands
you know
are
what
there?
we can do? What we can do? I just realized something we can do. Okay, let's change this from no back to a load, just so we don't forget.
Yeah. Sounds good. Right, because then we've loaded our 0.
You know what we can do? We can just go... Whoops. We can go out in the program, just to a different place, and add some code so we can test it.
Okay.
So let's add an input. Let's input. And let's add 5.
Sounds good. And then output. Yeah, okay.
Let's instant add 1. And then we output. And then we hold.
Okay,
So,
run that.
Run that.
Let's just do,
Let's just do 1. So it's going to input 1. It should add 1 and then output. It's working. Shit.
Okay, let's try loading something.
Let's try loading something. So you know what?
Wait, let's just store and load the same variable.
We can just manually store something.
Yeah.
So I'm gonna manual store like instead of, so this will be so this will be our store. This will be our storage, and then here I will change this. This is no longer going to be an add. This is going to be load instantly from there. Output and then stuff. So
okay, well I think you need to use the lower 2.
No, it should. This should work.
It takes the lower 2 tries, and then.
Okay, maybe you're right. You might be right. Oh, I know. Sorry, I know. Yeah, my bad. I just assumed you were right. Okay, 1. So that should be a storage of 1.
Okay.
Now, I will run it.
Nothing happened.
It didn't.
It didn't load.
It didn't load. I think load is broken.
Yeah, but what is it swap with?
It's a good question.
Oh.
Wait, we can check. We can look at the accumulator. Right now, 2 is in there.
It didn't. Oh,
but we don't have an add command. But okay, let's see if 2 is still in there. It will probably. I think it will be.
Yeah.
So it's not changing the accumulator. So it's not any of the like divides. But it's definitely not.
I reckon it might be a stack command. No, but it has to be used in our program, right?
Oh, I think it does.
Wait.
If it's, I will swap the instructions for 2. It just says 2 instruction codes in my architecture, but it also says your code will break. Maybe it changes one thing that you definitely have to one thing that you might have. You know?
Yeah. It might be a stack command.
It might be a stack command.
So just change the load to a bunch of different commands and then see what one loads. Like.
True. Good point. Okay. Everything that doesn't affect the accumulator, let's go. It's not input, it's not output, it's not load, it's not set. It's not any of these. It's not this load, because it would return something.
Yeah.
It's not setting anything. That's a little bit scary. I hope, because that is worrying, actually.
Yeah, because
if it changes, like, if for a future one, if it swaps a command, we have like a set command and set something in our code to some random shit, we're not gonna know. Especially if our code's long.
Oh yeah.
I hope they're pre-programmed, but if they're pre-programmed, they definitely did that for one of them.
Oh. Okay. It's not add sub multiv.
It could be though, because if it is, no, wait. If it will be loading this address, which is 1. Wait, it should be loaded. Yeah.
That's
no.
yeah.
It will be doing these with 1. It could be multiplying by 1. Let me change the 1 to a 2.
Oh wait, true.
As a test, change 1 to 2, and then let's run it from here. No, nothing.
Okay.
What
if it's a jump? No, because
no. We already tested.
Yeah.
The jumps are all normal. It's not comp because the flags aren't changing.
Try push. Just replace it with push and see what happens.
Replace it with push. Replace load with push.
Yeah.
Okay.
Actually, push accumulator. I don't know where the stack is, so hopefully it doesn't. We can't. I don't know if we can actually see. Okay, nothing got loaded. Fine. Let's try.
Into the stack. Where do we see the stack pointer? Let me look at the diagram. Is there a way to see the stack?
Oh wait, one of these I think is the stack pointer.
Stack pointer is the bottom one.
Okay, it has not updated.
Register. What is the data register? Is the data extracted by the machine from a memory cell? Points out. We haven't been looking at these at all.
No, wait, but what's this one's changed to 2, right? Because
that's the data register has been changed to 2.
Because that's the data in our.
Extracted by the machine from a memory cell, pointed at by the address register. The address register is this. That's containing something pretty big as containing 222, 221.
Oh, do you want to calc that?
Yeah. Wait, I can check what this is and subtract 2 from it. So it would be 3, whoops, it would be 3 times 3 times 3. Because this goes up to, no, this is 1, this is 3, this is 9.
Yeah.
So 1, this is 3, 9. 9 times, 27, 81.
Wait, your laptop's at
243.
58% now.
729. It's storing 727, which is the last place we set, because set commands are normal. Set commands are definitely normal,
Yeah.
but load commands are not normal. Load has been swapped with something. We know load has been swapped. With what is the question.
Wait, what address is that?
What address is
that's that.
This
no,
is
what's
empty.
that? I mean,
That's 2. That's the last thing we output when we did 1 plus 1. When we tested 1 plus 1, we got an output of 2. And because 2 is still in the accumulator, because we're not overwriting it with anything, because load isn't doing anything.
what if it's swapped with no op?
Nah, we've run a bunch of. We've run a bunch of nodes.
we would have seen it.
We would have seen it. That would be funny. But we have run a bunch of knobs and they have done nothing. So. I've got a charger here for the laptop. I'll just unplug like this thing.
Yeah.
Okay. We're gonna need a snack for the next 2 if this is going this badly.
Yeah, right. Hold on. Let me pull
If
up
it's
that.
not an easy command, the swaps suck.
Speaking of, what if it's swap? No, because that changes the accumulator.
Well, it's another.
Maybe
snack
return. No.
It could be push. It could be push.
Takes a value.
Well,
And
we tried push, haven't we?
yeah, it could be pop, but that affects the accumulator. No.
But if there's nothing in the if there's nothing in the stack, then it wouldn't.
Yeah.
It will be ignored if the stack is empty.
Let's
Let's try it. Let's try it. Oh, I'm not tabbed in. Let's try popping, which is F. Let's try it. And see if it loads. Which would load 2. It would then... Oh, it would then output 2. I need to change this back to...
Increase
I
that.
need to change it to 3. No. Nothing. Call? Push the current address of the stack.
No, because that would jump to the address in the instruction.
Return.
That also jumps.
Not if the stack's empty.
Ooh, true. Push something to the stack.
You want to push to the stack?
Yeah. So hold on.
Okay, how about let's get rid of this. Oh, well, let's keep this because it's easy to call to. Let's keep this as a value of 2. No, let's keep it as a value of 3. Let's go here. So what do we want to do? We're going to start here.
We're going to push something onto the stack.
We're going to push to the stack. We're going to push to the stack. We're going to push.
So we need to load something. Wait, but how do we load something?
No. Oh. Push the accumulator value. We have 2 in the accumulator.
Oh, okay. Cool.
Into the stack, which these 2 don't do anything. It's just a push. It just pushes accumulator value.
As once the stack pointer, yep.
Then, for the next line, currently we're outputting. Instead, should we pop? Push pop?
Yeah, I think
Let's
push
instant
pop.
push pop, see what happens. Push pop. So retrieve, which I assume puts into the accumulator.
And then the accumulator should stay the same, essentially.
And then we're halting,
Yeah.
which is fine.
We can't see the accumulator.
Well, we can, it's up there.
Oh, I see, yeah.
The stack pointer changed. It changed to 1 and then it subtracted. Push and pop and normal.
Cool.
Push and pop and normal.
What were we going to check? Oh, we were going to check return, weren't we?
Pop a value from the stack, take it as an address and then jump to the address after it. So instead of pushing 1...
we'll push 1 and then instead of
What if
pop,
we-
we'll just do return.
Huh?
Just do return instead of pop.
So we push 1 and then return, but
return.
then we go to 1.
Yeah.
I guess that's fine. It just seems a little bit annoying, but... Well, we go to 2, but still. Okay, so we're going to return.
Yes.
Okay.
Oh.
Did that jump to the right place?
Yeah, that's
yes,
2.
it did. No, it did jump to 3, which is 2 and
3.
then 1 after.
Yeah, cool. Oh my god.
Push the current address of the stack, then jump to the address in the instruction. I see. I got it. I know what that does. So basically, it would. So let's say we're like in this line. It would push this address to the stack and then jump to the address that we tell it to. Let's check what that's doing.
Let's jump to like maybe like here or something.
Yeah.
Or maybe like a couple of things after, so it isn't. Or just put a halt somewhere and jump there.
Oh, no, I'll just jump later because then we can manually stop it if we have to.
Yeah, true.
Yeah, it did it.
Hmm. And did it? The stack pointing increase?
No, that's not the stack pointer.
No, wait.
This is the stack pointer. But it
Wait, it should increase the stack pointer, no?
But it didn't load. It should increase the stack. So this should push the stack, and this should also push to the stack.
Wait, hold on. Yeah, run it again. So.
Oh no, it did it.
Oh,
It did it. But when we stop it, the stack resets.
Yeah, I see.
Resets. Ah, okay.
Got it.
That's also normal. Oh, the stack function's fucking normal.
No.
Swap. Let's try swap. Swap the accumulator value,
with the top
which
of
is like a bunch now. I don't know what value that is, but it's high.
With the top
and it would
of the
swap
stack.
it. It would swap it to 2. So after this, it should be 2. Let's reset these back down.
Yeah.
And then let's change this to swap, which is this. And then let's see what happens. Oh well, it would swap it in and then swap it out.
Yeah. Okay, just wait. Swap the accumulator value with the top of the. Wait.
Did it do it?
Hold on. Wait. So we push to the stack, and then.
Well, we can move back a little bit, and so we can push twice to the stack or something, or we can like.
Well, it's not the wrong command because it would have loaded something, surely.
What we can do is we can. I think we can. No, we can't instant load, unfortunately. But what we can do is we can go back here. No. Okay. What I'm gonna do is we're gonna start. So this is 3 in here.
Yeah.
What we're gonna do is we're gonna start on a load command. I'm going to load that address, which will load 3 into the accumulator. We will then push it. Then we will load something else.
Just hold on, wait.
Load something else and swap it.
Yeah.
This is also just a better framework for testing in the future.
Yeah.
So I'll test this, which is then a different address that we currently have nothing in, but I'll put like 6 in, and then we'll swap,
and see what that does.
and then I'll halt. I guess just for convenience. So we're starting here.
Yeah.
No.
Right. Yeah.
Yeah, we're starting here. It worked. I think.
Well, the accumulator weight. Yeah.
So the accumulator was set to 3.
Yeah.
It was set to 6, and then it swapped 3. It worked. So it's not any of the stack commands. God, this is annoying.
Wait.
It's not any of the stack commands. So we know load is messed up. Why don't we go down a checklist? Why don't you add in your notepad like a bit in the bottom, 0 to 26, everything we know isn't swapped. So 0 is fine. 0 is good. 1 is good. 2 is good. 3 is bad, we know that. 4 is good. Wait, let's completely test 4 again. Let's go. I'm not typing. Let's go back let's reset the temporary code that we were using. I'll just reset all of it.
Yeah, and then we can set one, and then we'll set one of these or something and see if it changes.
Yeah. Well, I'm going to go back here. I'm going to change this to a set command. Set.
Yep.
I think it will work, but just so we know, I will set that.
Do you like
that address
to
where
is that?
Oh wait, that's only what's in the accumulator value. Never mind. I will set this address so that you see where there's currently the 6. There should now be what's currently in the accumulator.
Okay.
That didn't work.
Wait, have load and set been?
I don't think so because the accumulator didn't change.
Wait, what's in?
So, this should be setting the address, the accumulator value.
Yeah, which is that one, which is not what is in the accumulator. What? Oh my god. Wait, do we use... Oh, so I guess it was the set commands.
No, the load was definitely messed up.
The load and the set...
No, wait, we're fucking stupid. Isn't set... No! We've been loading in our tests and it's been working.
Oh my god.
It's
set. Okay.
Wait. Let me just check. If I load it from there, it should change the accumulator value. And it does. Load is fine. Did we just forget?
I think we forgot.
What? So fucking confused. Okay, set is messed up.
Right.
Load is fine.
Okay, right, wait. So now we can go back to tracing from the start, right? Because we do our input and then we set everything. So obviously it would jump if set has done nothing to the accumulator. Wait, but hold on. Oh my god, this is so confusing.
Yeah, I'm confused.
Because
it's about to start the program. So if our sets aren't working.
Oh right, because we set. No, because we set 727, and then we load it, so it must have been set to 0 somehow by the set command. So do you reckon?
So the set isn't working. So we're setting, so we're inputting, but they're not being set anyway. It's doing something else.
Wait, check. Oh wait,
I can actually confirm this by doing this. Because now it will set to an address that we can very easily find. Yeah, I can just continue with 1 in there. It'll set, and I know it has.
Oh, it set a flag on the accumulator. Oh, on the ALU.
But wait, I just realised this.
Wait, run it back.
This second input did not do anything. That's very strange. But if I go check the address, it's empty.
Yeah. So
set is messed up. Okay, cool.
And then that's why it's loading 0. So wait, it changed an accumulator flag, an ALU flag, I think. Run it again.
So if I'm setting in the correct place, so first we got an input.
See?
And then we got an input.
So it must be either add or subtract, because those are the only ones that can change the flag.
Oh, it's got to be subtract, because it's underflowing.
Yeah. Okay.
Is it instant subtracting? Because it could be instant subtracting.
Well, we've got 0 here, so it wouldn't underflow.
I mean,
wait,
no,
we're
inputting 1. If it's instant subtracting, it's underflowing.
Wait, increase the value of your input.
Yeah, what if we input 999? Like, what if we input the max? Because it's subtracting the max. So if I input, and then we input that. No.
Doesn't change the flag.
I think it's instant subtract.
Yeah, it has to be instant subtract.
Because then because it wouldn't overflow, it would never overflow. Does it have to be instant subtract?
Yes, because
I think it does.
we changed.
The value in there is not being set. It was set ages ago.
Wait, do 998. No, do 98.
98. Oh yeah, true. Because that'll confirm it.
No. Okay, fine. What's at that address?
That's the last address.
The last
I
address.
can't circle around to it.
But
so we don't know.
It's maybe
we
a
don't
previous.
know.
Wait, but it has to be subtract.
This is subtracting something.
Well, there's only 2 subtract commands.
What if we? Yeah.
Let's just test them both.
Subtracting? Yeah. Okay.
Well, it's underflow, so surely.
Oh wait, true. What if we? Okay. Let's go back to our test area.
Yeah.
Let's have an input. Let's input. Let's set, but use subtract as a set. Let's do instant subtract as a set,
And then
and set it to like. Do you see that? You see that address? It's
there.
this
Yeah,
one.
cool.
So now, sure, I'll just.
No.
Didn't
Okay.
do it.
And then
But
change it to the other subtract.
wait. Oh, but it did correctly subtract. It did correctly subtract.
So then.
So it's not sub n, but it
So
might be
try
sub,
sub.
which is normal, which is 12, which is that. So then I'm gonna go back here. Let's do that. Sure. No, it didn't work.
What?
It didn't work. What if I go to that address and we put in like we put in like 1.
Okay, yeah. Try that.
Because then if it's subtracting,
Yeah, and
and then so it's 99, so we can very obviously see.
and then it should.
It
Wait,
is
did that add 1?
No, it's subtracting. It's doing
What?
it. It is doing it correctly.
What is happening?
But if we just do the default set command,
Yeah.
it's not going to set. So if we set, if we input and then we set, it's not setting. But if we input 0, it should underflow like it was before. If we input 0, wait, let me go. It's underflowing.
Yeah.
That's the F flag. I'm sure. So the F flag is the let me find the flags again.
There.
Yeah. Second indicator F flag will show if nothing strange happened. Overflow doesn't happen. If underflow, which means it went below 0, which I don't know how it's doing that unless it's subtracting.
Wait, but look. This flag is the vertical bar, which means that it's greater than 0.
Oh wait, good point. Well, the accumulator was above 0.
Yeah.
There was but I think I guess it was an arithmetic operation.
What arithmetic operations are there?
I believe I want to test.
Oh.
Okay.
Wait.
If I go back, if I go back and we input, let's input 99, which is 729. Let's input that. Then the accumulator has this. Some arithmetic operation has happened, even though nothing has happened. The accumulator.
Wait,
has
what
not
about
changed.
what about the one where it does it without doing it?
It could be comp.
Yeah.
Oh my god, you're so correct. Wait, we didn't even think of that? Wait, comp acts as if it's subtracting, but only the flags.
Oh.
We are stupid.
Wait, test comp.
comp right now. Oh my god, if it's comp, we are so dumb.
I'm actually gonna crash out.
We're so dumb if it's comp.
No.
We're so dumb if it's
I
comp.
can't believe we overlooked that.
There's no way. It's fucking comp. No! We've been on this for like 15 minutes.
Oh. Okay, at least we can fix our program now.
We got it. At least we can
got
finish
it.
this shit off
We
and go
got
get
it.
some snacks. Okay, these are oh my god. Wow, we're dumb as bricks. At least, hopefully for next time, we should now be able to do it a little bit faster.
Yeah.
So we get some. Again, If it's easy, it's easy. If it's not easy, it's not easy. Okay, comp and set have been swapped.
Okay, so there's a set on line 1.
There is a set on line 2. Whoa, yeah, line 1.
Yeah, let's just...
Line 2, but line 1.
Yeah.
Okay, so this is a set. So set is for comp is 20. I know what the comp thing looks like. So our set needs to be turned into a comp. That is now turned into a comp. Okay. Another set. Another comp. This is a set. After the jump, I believe that's a jump.
Yeah, that's jump Z.
After the jump Z, there should be another
Set.
That's correct. Okay, cool. Changed. They're like, I think the furthest instructions can possibly be to each other in terms of moves, which is a little bit annoying. This is a comp, which should be a set.
Yup, and then...
Oh, actually, no, I found a faster way. Then there's another set,
Yep. This should be a comp.
which we need to change to a comp.
And then there's another set after a none.
Yeah, there is. Okay, is that?
No,
And
we've
then
got
there's
another
set.
one.
There's another set, which I'm changing to a comp.
Yep. That's it. I
That's
think.
it. That looks like it to me.
Okay.
Well,
have we
testing mode.
accidentally destroyed our code in the process?
Let's hope not.
Okay. Let's see here.
Wow.
Are we locked in? I mean, it looks like it's working.
I mean, we're using everything except the stack, but like that's kind of how I treat programming normally. I just don't use the stack.
It's just, I think it's like it's a convenience thing when you're doing like functions and stuff. If you want to send like arguments to your functions, you push them onto the stack, and then you pop them off in the function like body.
I am actually very scared now that we're gonna run out of storage space. My computer's been weird about it before, so I think I'm gonna delete a couple videos just to make sure.
Yeah. Okay.
Like, I know we have like 200 gigabytes, but my OBS has been weird about it before, so. I hope we're not in an infinite loop here. This looks bad.
The accumulator is not changing.
This looks very bad.
The accumulator
Which part
has not
of
changed.
the program are we in?
It looks like we're in the second mini loop, possibly.
I believe, yeah. Because that's the initial sets, and then. Okay. Let me grab this.
Hold on, yeah, I'll do this.
So. That's fine. That's fine. That's fine. Which should we jump in there? We're not underflowing. We're not. Okay, we're just never underflowing. So I've got the issue.
Yeah.
We're comping 727, and then we're never underflowing.
What is the? It might just be that with all of that nonsense, we've set these variables really high. Oh, someone's calling me. Yeah, hello? Yeah?
I'll end it.
Yeah. What? Oh! You bet. That's rubbish. Oh my god. Did you get voucher or cash? Oh, shambolic. Okay, that's acceptable. I don't know. Whenever. I'm kind of locked in right now. Yeah. I'll swing by when I'm done. Yeah. I'll track you. Okay. Wait, what grade did they sell for? Oh.
What's that?
My brother's selling my old phone.
Oh, okay, cool.
This guy was like, "Yeah, I sold your phone for 60 quid." I was like, "What is this guy on about?" Okay, right. Where were we?
Because we like can't check these memory locations.
Yeah. Right.
And
so
we don't know what input data they're using.
Well, surely it does it not show?
True. Are they using the input data that's there? So I'm thinking. So something's up. So it's meant to be comping. It's not. So
yeah.
where
Did we actually change the comp? Hold on.
Yeah, that's kind of what I'm thinking. Where were we stuck? So this, I believe, there's a none.
Yeah.
There's a load.
And then
load
there's a load.
728, and then comp 727.
Yeah.
Which is that with the set command. Jump UF. Maybe we were wrong.
Surely not.
There's no way though. There's no way. There's no way we were wrong about setting comp.
Wait. Let's watch the flags when it's looping because. Wait.
The
Why?
flags just weren't changing.
No, the fact the accumulator wasn't changing is.
Yeah,
Well,
something was up with the subtraction. Maybe somehow it was 0. Somehow
Right.
something got set to 0.
Hold on. Right. So we. Yeah. Wait.
Somehow.
Wait. So we're in this loop, right? The after the none, we load.
We
comp, and then
nothing happened. So the flags didn't change.
But
so
did we not jump back there?
UF. We did not jump UF.
And then we sub.
Because the flags did not change. The F flag is still circle.
But
we
the sub
didn't do anything, which makes me think 727 somehow has nothing in it.
Yeah, it's empty.
Wait.
Did we change that set command?
Wait a second. Did we ever add 5 to our 5 value? Wait, how did the rest of our code work? Wait, okay. Let's go back.
That is quite an incredible question.
So we load 0.
Yeah.
So we load the place that currently has 0, and we say we add 0 to it, and if it has 0, then
Wait, why do we need 5?
because it needs to start with 5. Oh no, I'm thinking of last time.
Yeah. No, I got caught up with that. Yeah.
What we're doing? Wait, pull up the Python program.
Yeah.
While b is larger than 0, so that's our temp. Sorry, I was completely like with with the thing we did last.
Because we've got like 2 nested loops, and I was like, yeah.
Okay, so temp is b. So what we've done is so let's go back to the Python program. We've got a, and we've set it. We've got b. We've stored it. Then we have loaded an empty location.
No, we haven't. We have
loaded.
We have loaded B, which we stored.
That's not loading B.
Okay. Oh, remember when we were changing load, and I was like, change it to a no op, and you were like, oh.
Oh my god.
And I was like, oh.
And then I had it in my head that we were doing the previous program.
Run it back.
Fuck. My bad. Okay.
No.
Was that actually the entire issue? That might have been the entire issue.
Always doing stuff. Okay, wait.
Wait, but that's setting the wrong value.
Okay, wait.
I believe.
Wait, let's just see what
I believe that's setting the wrong value. Let's see what happens, but I believe that's setting the wrong value. I think we're stuck in a loop. No. We're not stuck in a loop.
Oh.
So it was just me. It was my fault. Okay, it was my fault.
Alright, let's go to the car. Wait, do you want to delete some stuff and then we'll go?
We need snacks to delete everything. Okay.
Oh.
For everyone watching the raw footage, oh my god, it's been 2.5 hours. We are going to the shops. We'll be back in.
Who knows?
Back in like 10 minutes.
Yeah.
I need to grab some milk and eggs as well.
Oh yeah.
It's been.
I'll actually remind you.
Because you know what, for some reason I thought 6,000 seconds was 1 hour.
Yeah, you were talking about. Oh, I've been here for 30 minutes, and I saw taking on the timer, and I was like, wait.
That's not how that works. Oh, I need my keys. Okay, so that timer is actually at like it's more than 2 hours. You're gonna be
Wow.
on.
No, it's true. It's about the journey, not the destination. Okay, that's because we all have.
We gotta reset the code now. You want to try writing something on Python
Right.
while I reset the code?
Cool.
My chair is stuck.
My chair is broken.
I was thinking. Oh no, my chair.
Okay.
Okay.
Time for thinking.
I'm not tabbed in.
Right, let's figure out the representation we need first. I'll have a look.
Oh wait, no, you pull it up on here.
Oh, I can put it up here.
No, I got it.
Oh, cool.
Oh, 'cause it goes up to 2047, yeah. Makes sense. Look,
Okay.
I think if you calculate that, it'll show it makes this.
Let me. With my calc.
Yeah, with your calc. Short for calculator, by the way.
Yeah, anyone uses the chat.
Mm-hmm.
What's the one after 81?
82. 243. You have the calc, why don't you just multiply?
Yeah, it does work. Well, because I'll lose my current expression. Oh wait, yeah, I could just... I'm a professional, I swear.
Mm-hmm. Professionals have standards. Cookies are kind of mid, to be honest, but you can try them. Not like bad, they're just...
Alright. I'll have it. I'll give them a go. Right. What's the largest place value? 27. What is that?
243.
243. Amazing.
So we just start at 243, and then every time we redo the loop, every time we exit the loop, we divide that number by 3 until we get 0, which we can check for with a flag, because then 1 divided by 3 will be 0, and we check that with the flag.
That's good.
The flags seem so weird, but they're so helpful. Like, genuinely, everything you could ever need to check is in overflow, underflow, and is it 0 or not.
Yeah, I know. It's like, it's just like, they didn't, like, it feels like it's, oh, when am I going to do that? But then, yeah, it's actually, like, whoa, let's go to. Okay, designer of this instruction set, absolute go.
Like, if we can do this, and then we don't get an A star in computing, it's a scam. This is proof we deserve it. This should be the test. This should be the computing A level.
I think from the spacing between the numbers, it's separate, like, outputs.
Output it one by one.
Yeah.
Oh. So I assume it outputs left to right, because that would make sense.
Yeah.
This seems so chill. This seems fine. But but the thing is, because it's long, it's going to be hard to debug at the end. Okay. Oh, I just realized I could accidentally exit the level right now. I'm putting on confirm exit, confirm all, so full reset, confirm practice, confirm reset.
Yeah.
Just in case I accidentally hit R or something. Okay. Well, we're only inputting one number. I'll write the input right now. Input store. And I'll set it in just our normal storage. And then if we want functions here, I can put in a jump. Do I want to put functions right at the start?
Yeah. So
Let's do it. I'll put in a jump.
and we can set that later.
Right, so I'll jump always. Well, we were none. This is our first function. It's going to be mod function?
Yeah, I think so. If you want to program a mod,
Oh, but the thing is, I guess we could load and then do the function, but the problem is, if we can't really make general purpose functions because we have to load a specific address right at the start.
what do you mean?
Like, for example, if we're doing a mod function, we always need to load from the same address.
No,
But I
you
guess-
can, that's what the stack is for.
Good point. But I haven't used that before.
Yeah, I'll need to figure that out in a second, but...
Let's take this.
Oh, cool. Here, do you want to program this? Well, I think about the stack.
You want to do that?
My brain.
Do you want to swap round? Well, actually, I've been using the UI.
I can't use the UI.
Yeah, you
I'll
can't,
just
you can't
think
use
about-
the GUI. Yeah, don't
I'll
sweat
think
it,
about this.
just think about it. Okay. Showing me 377. Where'd 243 come from? Oh, yeah. Well, okay, well, we're not starting at 243, we're starting at 49. No, 729. I'll make it current. Did you get cookies on my trackpad? Yeah, you did. Car equals 729. Okay. What is B? I hate your variables. I'm restarting.
No, I feel.
Yeah, num is that. That. Okay. So now, I'll write it in simplified Python because then we can expand it later when we have to.
Yeah. Well, that's what I was thinking. I was just gonna draw a stack of things, but.
Well, I'll write it in very simplified Python, and then we can expand it again later.
Okay. I've got a plan for the functions.
Wait. I've got it. I think I've got it. Let me check if this works. It doesn't.
Ah.
Oh, wait. No, I know why. Oh. Yep, got it.
Yeah.
Take a look at this, see if you get it. It's very simplified, but again, that's because we can expand it out later. Do you get what it's doing, basically? Do you get the concept?
Oh, yeah. Okay, wait, so we do... Oh, yeah. Then we divide by it.
That gets a lot longer in assembly and a lot longer in geometry dash, but...
Yeah. Well, we don't need it. You skip the string concatenation, you just output immediately.
True. Good point. We can output within the function.
Hold on. I'm gonna put this down and then wipe my hands, and then I will expand it out a little bit.
We're like L.
Oh my god! Yeah, that one scene.
Yeah, with the snacks.
even algae water is good.
Mm-hmm.
Okay.
One thing I'm a little concerned about is I don't think we can have 749.
Why not?
Because 27 times 27. 729 is 27 times 27. But we can't do that. Because 27 times 27 is that, which is input. So
yeah, but we don't. Instructions and data are the same thing, so you just load that. You can't use it. It's not.
I know
immediate.
what you mean. I know what you mean.
You'll have to hard code it somewhere and then load it later.
When you direct, yes.
You could just direct an input instruction or whatever, just like
Which
line one.
my line 1 input could also be our 729.
There you go.
And then we can divide it by 3 every time. Got it. Okay, that works.
Okay, integer division, yeah, that works out beautifully.
Okay,
so I think we start with our loop. So
I don't think we need to do function.
We don't need
we
a
can just do
function
it in order.
Yeah. Are you gonna finish this last one?
No, you can have it. If you like him, you can have it.
Alright, let me put this down so I run it up.
Yeah. That'll be a crummy situation. Okay.
Start with our know what, and then we'll divide our input by our column. Oh wait, let's
Wait, I just realized if we use the first input, it'll be like changed.
we don't. We'll store it in a different variable. That's what I was about to say. We'll just load it and then store it somewhere else.
Oh, true. Wait, oh yeah, so why don't I do that now?
That's got to be our first line, yeah.
I'll do that now. Wait, shit. I'll quickly load 0, 0, and then store it in there in 720. If you're writing this in Notepad, which might be a good idea, like we did before, that's we've got those lines.
We'll do it on paper.
You sure?
Well, my hands are kind of.
That's fine. So we got input. We got set 728. And then we got load 0. Set 727. So 727 is current. So now, I'm going to loop 7 times. Oh, should we get a counter? We get a counter of 7.
Yes.
Okay. We'll do the same thing. I will load 726.
Yeah. Should we say it's a 7? How do we load immediate? I can't remember what instructions. Can we set immediate actually?
No, you
Okay,
can't set it. You could not set immediate. It's been annoying.
It's
Well,
rather
it's not a big
strange.
deal.
Don't we just have to like load, add, set?
Yeah. So that's what we did before with the counter to 5. So what I'm doing is I'm loading 726.
Yes, because it will be 0.
Because it'll be 0, and then we're gonna instant add 7. Yeah, and then we're gonna set 726. Cool, we got a setup.
Right, and now we have initialized. Okay, now we start our loop.
Yeah, I've got a none to start. Just make sure you have that. Then
let's check our. Should we check at the start or the end?
Let's check at the end because right now it's 7. We'll
Yeah.
say we'll take away 1. Oh, but then if we do 7, 6.
Well, it doesn't matter. We can take
5,
away
4,
and then
3,
check,
2,
or we can take
1,
away the
0. Yeah, take away. We have to take away and then check.
Yeah.
Wait, if we take away, we can check if it's 0. We don't need to check underflow. We need to check 0.
Yeah.
We take away and then check the Z flag.
Right. So we'll do that later.
This is fine. We'll do that later.
Okay. So we need to divide our input by our current power.
Okay. So load input.
Oh wait, we need to create. Yeah. Well. Yeah. Divide. Load input.
Load input. Then divide by current.
Yeah.
Oh no, it's not. It wouldn't be 8. It will be 14 because it's divide by the address.
Yes.
Yeah, divide by so div, not div n, div 728, which is where we have current.
727, surely. That's current.
Oh, 727. Sorry. Yeah. So we load number.
And then we've divided our number, and then we need to store that in our new variable.
True. Well, no, we don't. We just need to output
We just
it.
need to output that, yeah. So just then output.
Then we just output. This is why I said this is going to be the easiest one so far. We output. That's our first output. Then we need to load current divided by 3. Yeah, we need to load current. Div n
3
by 3, and then set into current. Sick. So we've done the thing.
Now we need to check our if.
Check, and now we need to load the counter. We need to instant subtract.
1.
No wait. Instant subtract 1. Now we need to jump Z. We need to jump Z.
Yeah.
I'll leave the address for now.
Yeah, and then.
Oh wait, but this is the end of the loop. Basically.
Yeah, so just wait.
It's fine. I'll do it in a sec.
Jump Z.
Jump Z, and then if we don't jump Z,
We have a jump to.
we have a jump always back to the start of the loop,
None, yeah.
which is which line's a none? It is that line.
8.
That line. That line's a nine.
Cool.
Okay, that
And
seems
then-
like it works.
And then we'll have another separating.
Wait. Did I mess up? Give me a sec. If we do not jump Z, then we jump always. But I
Yeah.
just updated the wrong one. Okay. I updated the wrong one. So the jump always comes directly after the jump Z. That's
Yeah.
correct.
And then there'll be a none after that, and then you can change the jump Z to the line after the
I'll
after
put
the
an
none.
input there
after the jump.
so that we know it's this line, which is that symbol. Okay, and now this line, we've just...
Wait, this is the where we check for 1, right?
Wait, this is the end. No, we're done.
Yeah, we can just help.
Wait, what the fuck?
wait, I think it's just done. Like,
Wait, are we...
I think
There's
just change
no
that to a whole.
way.
Just change that to a whole.
Yeah, it is. Wait, there's no way that's it. I did say this would be the easiest one. I'll quickly check if this
Yeah,
works.
put the testing machine on.
There's no way this works. If this works, that's so goofy.
That is.
Did you get stuck?
Oh, it didn't work.
Where did I get stuck?
Oh, I didn't like our output, I think, and it just stopped.
No, it didn't stop at the output though.
Wait, what?
We stopped at like a random place. Unless I held... Let's try it again.
What?
The bug, it just...
What line? What command is that?
Does actually load. I was trying to load something that doesn't exist. No. We should be loading current.
What?
Oh, it's directly after the output. Yeah, it doesn't like.
You must not like the output. Maybe we're doing it in the wrong order.
It outputs and then. So what it should be doing. So this is the second, but this is after the second output. We've already outputted and we're outputting it again. Maybe the second output is wrong. Maybe that's the
right. Okay, let's test it on our own data real quick.
Okay. Well, it's input with A input.
Yeah.
377. Okay, what is 377 in this? That's the question. Okay, 377 in the 27s is... Well, we can convert here.
Oh, right, yeah.
Surely. Okay, you know what? Actually... Wait, I can't change anything right now. You know what? I'll end the program. And then I will do a test, which is if we do, so it should be, if we do, so 2,
yeah.
If we do 2, 2, 2, 1, 1, 1, so 0, 1, 1, 1, oh, but that's not 0. So if the first one was 0 and then it was 2, 1, 1, 1, 2, 2, 2,
yeah.
It would look like this, but with this first one being 0.
Okay.
So it's, wait, can you write that? So it'll be over, like the flat, the 0. Like the...
Wait.
Why are you writing? Let me... It would be that. Maybe that symbol.
Right.
Let me erase that real quick from this. If I run this, then it should be...
Yeah, and then it's like question mark. I think we went past it.
You sure? That's the wrong question mark though, right?
Yeah.
It's 13. No,
yeah,
it's like way later, yeah. And then that. This should be...
Okay, right, let's see what happens.
This should be it. Okay, so check our outputs. Let's look at the output. So the first time it outputs, it should be 0. It's 0,
yeah.
correct. Second time it outputs 1.
Mm-hmm.
I'll speed it up. That's not 1.
Yeah.
I think I know why. We're not subtracting number, are we?
Oh, yeah. Okay, we forgot. Right, hold on.
Wait, that means we're going to change a lot of this.
No. I think we should be. Do you know what we could insert?
No, we need to change all.
No,
of
we
this.
can insert a jump always to jump to a different line.
No. But Harry, if we do that, we're still adding a line, and then everything needs to be deleted.
No, we replace the line, jump somewhere else, add that line.
Yeah,
so,
but then but Harry, replacing one line breaks everything.
No, but like as in a fill-in section. So.
No, but we can't do that.
We replace the div n with a jump, and then we put our div n here.
What do you mean we replace the div n?
After
the output?
Yeah, right.
After the output, what do we do?
We replace the output with a jump.
Oh, I see what
and then we jump somewhere else, then output. And then do the rest of our code, and then jump back.
Sure. Sorry, my bad. Okay, I know what you mean. Okay, so instead of an output, jump always.
Yeah.
This is terrible, but
just do it after
fine.
the hole or something.
Yeah, it should be here. I'll put an input there just so we know. It should be the upside down trident thing. Oh well, they're both on screen.
Cool.
We're going there.
Right, and now change that input to an output.
Yep. Now we need to subtract the load number, and then subtract. Oh shit. Oh no! We do not need an output. We want to store it. No, we don't.
Yeah, because we output, then we.
I know what we do. We mult. We normal mult. We direct mult. by current because we still have new stored. Then we never need to store new.
Okay.
We direct mult, which is 13. We direct mult. That's a question mark. We direct mult by current, which I believe is that one. It is that one. And then, so after we've direct mult, we then, so we've done new direct mult by current, and we need to store that in number. Which is, we've used a set into 728, and then we jump back. This is terrible coding practice, but it does save a lot of time.
What do you mean? This is not terrible coding practice.
Well,
like if you're programming in if you actually had to punch this out.
Okay, fair.
Yeah, I'd be doing this.
I just mean that it's bad because.
Oh yeah, we should have planned.
We should have planned. I just completely forgot about that line.
It's fine.
Okay.
Right.
Well, this should work now. Well, let's put testing mode on.
Wait, did we add... Alright, did you subtract the... Did you do new subtract the number?
What do you mean?
Because it's number...
Mark.
Oh yeah, number... Did you do the number subtract? Because you did the new multiply by the current, but did you do number subtract? Whoopsie.
We're gonna need to store it.
Yeah, fine.
Okay.
Let's just have a temp at 725.
Okay. So this is the mult, and we're gonna need to remove these two lines. So, no, because we can't. Because what we're doing right now is loading, so we just need to remove this load.
Wait.
No, it's fine. Trust me. I got it. We're gonna remove the load, remove the jump back, because we're gonna move them back a couple lines.
Yeah.
So we've just done new times current, which is now in the accumulator.
Yes.
We then set that in 720 in that one.
725. Yeah.
Yeah, 725. Then we
load new. We load.
Yeah,
we load number.
We load num from 728. We direct sub, which is 12.
What direct?
Yeah, we direct sub from the place we
right,
just stored, which is 725. And then that is new number in the accumulator because we just direct subbed, and then we set in
728.
In 728, and then we jump back.
Cool.
Yeah. Yeah. Oh yeah, because before we just set numbers and new terms. Okay. Now we always jump back to question mark, I believe. Where do we always jump back to? Oh wait, this is our first always jump. No. Okay, let's go all the way back up to the top. So start of the loop. This is where there was the output. We need to jump back to backwards 6. We need to jump back to this line, right?
Do the load.
Which is this line. Backwards 6 is line 11. That's line 11. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
Yep.
Yep, which is backwards 6. Cool. Backwards 6. Now, this should work.
For real this time.
Yeah, FR. Oh wait, whoops. I started it not in testing mode. I told you this would be the easiest one, and it is. We've just messed up multiple times.
Yeah, the first night of these games is usually.
We've just not been paying attention, but this is actually the easiest one. Assuming this works.
I mean, it appears to be. Okay. It's still running.
It stopped
Yeah.
after another output. It outputted the wrong thing.
Okay. How far did we get?
Quite far. But the thing is, it worked for all the first ones and didn't work for whatever that last one was.
Okay.
So I'm thinking maybe we're looping too many times.
Yeah. Possibly. 7, 6, 5, 4, 3, 2, 1, 0. Yeah.
No, but the thing is, we always subtract.
We're looping 8 times because.
Are we though? Because we're subtracting and then we're checking. We're subtracting and then checking if it's 0. So we start at 7. We do the whole first loop. 6. Do the second loop. 5, 4, 3, 2, 1, 0 is the seventh loop. It checks if it's 0 and finds it is 0.
Okay, let's run for our test data and watch what it outputs.
Yeah, we've still got the what was it again? It was
mark.
Question mark, and then
9.
9.
Awesome.
Should I hold W for all of this again?
Okay, right. Should be a 0.
Oh wait, did you? Oh yeah. 0.
I've written it down.
1.
Should be a 1. 2 ones, right.
And now.
Another 1.
Wait for it to loop again. It was another 1 because it didn't change.
And then there should be 2.
No, it's another 1. No, that's correct. 1, 1, 1. Now it should be 2. Back.
Okay, right, yeah.
There's 3 1s.
And then 3
This
2.
is 2 number 2. That's 2 number 3. And now the program should stop if it keeps going. That seems to be the issue. Now it's done 0, which is where it broke. It's our ending detection is definitely the thing that's wrong.
Okay. How did our loop go so wrong? Right. Where's the jump for our loop?
So, well, the loop's not the thing that's correct, it's just our end detection. So let's find the end detection. So after this, which was the old output, we then load...
We should load our counter.
No, well, we're loading current. So after the jump always, we load current, we divide it by 3, and we set current. Then we load counter, we subtract 1, and then we jump Z, I believe. That is a jump Z
As it should be.
to...
That, which should be a hole.
It is. So it's this. So the Z flag on this isn't updating correctly.
Wait.
Well, we can go through it slowly, see if...
Yeah, I'll see what the accumulator shows when it loads and minuses 1.
You know what? Because we've had the bug, the value might now not be 0 at the start. So what I'm going to do...
Just, yeah, set
I'm
it.
going to add a set.
Well, load, then set.
Well, I'm going to load it right now to check what it is. Oh, but it might have underflowed is the thing. So I'm going to add a load. Where's my mouse? I'm gonna add a load to there, and now I just want to see what it is. It has gone up to like
quite a lot.
That is a lot.
Okay, so let's set that to 0 because
so I'm gonna
it
change
won't work.
This load is now. I'm gonna now set. Oh yeah. So our accumulator needs to be 0.
So load one of those zeros somewhere
I'm going to go back to this previous line, and I'm going to load just this. That doesn't matter. No, that doesn't matter. Okay, I'm going to load 0, and I'm going to set.
Cool.
Now, if I now delete this load, and I change this back to a load instead of a set,
Cool.
it's 0.
Right,
now,
now let's run it back.
So, well, before we run it back, in case we cause another issue, let's just check. So, what it's doing is this is our division by 3 and set. And then here, we load the counter.
Yeah.
We instant subtract 1. And then we jump. If it now equals 0.
Wait, we don't store it. Do we?
You're so right! But fortunately, I put in a num that does absolutely nothing here, so we can add that super easily. Okay, thank God he found it.
Okay, right.
Well, that's our issue. We're doing 7 6 7 6 7 6 7 6 7 6 7. The 6 7 bug broke up.
Yeah, the 6 7 bug.
Okay, what do we need to do here? We need to do 1 2 3. We need to set. We need to set the counter. Yeah, because our current version of current value in the accumulator is the new version of the counter. And then, yeah, so that needs to be now set to the counter. And then here, we need to now jump always back up to. Oh, I forgot what line we're jumping up to. Probably the very first none, which
yes, it looks like the first one.
is the upside down question mark. We'll jump to the upside down question mark. There we go. Well,
Run
test mode.
Back.
Let's run. I only got a whole double. So the issue was that we were running too many times, but yeah.
Okay, well, this is going pretty well.
So the problem is we got about an hour, assuming you stay longer, but not like until dinner, to figure out next prime.
Maybe a little bit cooked.
Yeah, we may.
Oh, plus we have to debug those.
Yeah, true. Shit. We may be cooked.
Oh. Right. No. Oh.
What's
Okay.
it breaking to?
Oh, it's not jumping, is what's happening.
No, it is jumping. It's outputting too many, I think. I still think it's outputting too many.
Yeah, but as in, like, it's not jumping when it's 0, because
Yeah.
Wait. Okay, run it again, but not... I wanna watch
Not
it
in
this
test?
time.
You wanna...
Right. Yeah, let's do the test day, so...
You wanna do our test?
Yeah.
Oh, we might not be able to finish this in time. Well, if... but you'd have to stay. Or I'd have to do it myself.
I might have to look up a guide for the last one. Kind of cringe though.
It is cringe. I want to do it ourselves. Just, you know, we want to finish, so... Okay. 9. I mean the upside down question mark. I mean the normal question mark. 10.
Okay, right.
So, I'll speed it up. So the first
No,
output...
keep it slow.
No, well...
Okay, well, yeah, wait until it...
So we've outputted 0. Go back up. We've outputted 1.
Okay, and yeah.
Okay, what do we output this time? 1. That's the second one.
Hold on. Where's the loop decrementing?
Alright, what do you mean?
Where's the counter?
It's another
going
1.
down? There.
Here. Doubling 2. Wait. Make a good point. Let me check. Is it loading the counter? Counter's so big again.
Oh, how has it got big? Okay, wait. I think we must
You know,
be...
I'm going to stop testing it. I'm going to stop.
Yeah, we must be storing something in it by accident.
Yeah. So that's kind of what I'm thinking. So here, we're loading that for current. Unless I'm thinking of... no.
Because counter should be 726.
No, counter should be 7.
No, as in the address. Like.
Oh,
not,
yeah. When do we set up counter? Okay. So here we're loading this, which should be empty. we're instant adding that to it, and then we're storing it. Oh my god.
Is that not 7?
That's not a load command. That's a set command.
Oh.
That's fucking crazy. I think I just miswrote the command. Okay, let's reset it to 0. We need a manual reset to 0.
Leave the reset
I will
code
leave
there.
the manual reset code here. Set.
Oh, we need to load.
Oh yeah, we need to load 0. We need to move over. We need to set
Set 0.
that in that. Jesus Christ. I think I just literally just wrote
He's
the
running.
wrong
He's
set.
running.
I know. I know. I know what you mean. I know what you mean. I know what you mean. Sorry. I was like, I know. Okay.
Hello? Yeah. Oh god, I don't know. What? Hold on, I'm not at home right now. I'll sort it out later. Huh? Oh, I'll sort it out. No, not recently. Okay. Okay. Bye. That was my granddad complaining that the tracking app isn't working. Okay, keep running it,
The tracking app.
Well, you know I've got like, what's it called, Life 360.
Oh, I've heard of that, but I haven't like used it.
Yeah.
Wait, is it like tracking your location?
Well, as in like everyone in our family has it, so we can all see where each other are.
Do you not just use Google Maps?
I don't know, can Google Maps do that?
Yeah.
I don't know, as in like you can just like go on here and see.
Yeah, but you do have Google Maps.
Yeah, well my dad already paid for this, so he's kind of committed, you know.
Yeah, well, Google Maps is free, so.
But apparently it's broken, which it doesn't seem to be, so I don't know.
It's probably doing something wrong.
Yeah, user error. Oh, this is gonna take forever.
It worked for the bus test.
Wait, is the counter not being reset to 0? What's
No.
happening?
Oh, because we're not setting it the last time.
Oh.
That's
Alright.
fine. We can manually reset it each time, or I can change the code.
Just add a jump to that piece of code.
No. We just literally need to change the order of 2 lines.
Okay.
We need to. So this is the jump, and this is the store. Instead, we need to store and then jump. So I'm going to change this to this line.
So much for this being the easiest one.
It is the easiest one. We're just being dumb. We're just being stupid. It is the easiest one. In terms of like logic,
God,
it's the
we're
easiest
never
one.
going to finish the last
We're
one.
not.
It's not going to happen.
Because we do not have time. Okay. Jesus Christ. Okay. Let's make sure it's reset now. Actually, I need to reset it. Okay. Cool. And now it should be fine.
Yippee. Oh, I'm going to run this all over again.
And it'll be fine if I didn't have to hold W the entire fucking time.
I might make an emulator for this.
If I move my mouse over to the right side of the screen. Oh, it is the right side of the screen. Okay.
I think I might make an emulator of this in Python or something. Because I was low-key like, I wanted to do LMC, but LMC, the architecture is awful. Like, the instruction set is so small. This has potential. So.
I think we got 2 left.
Oh, okay.
Then we got one left.
Come
Last
on,
one,
come on.
last one.
Lock in, lock in.
Yep.
Yes.
And now,
And again.
and you see how the accumulator has a 0 in it because the 0 has just been stored. So now you should be able to run it again, and it should work.
Thank God. Okay, now we've got to debug it. No, I forgot about
We have an
that.
hour to debug and do the next one if you're leaving.
Oh, I'm gonna.
Do you have like a time you have to leave?
I need to like. I can push it, but like I need to like get there before like dinner is very much finished being served.
When is that gonna be?
Or like 7ish.
So you gotta leave here at like 6:40.
Oh, I can leave at like 7 basically. That's what I meant. Like,
Alright, cool. Because that would probably be fine if I asked my parents to like set up dinner around 7. Okay.
okay, it's fine. I believe these instructions will be nice and easy.
Yeah, it's gonna be input. It's gonna be halt. It's gonna be jump.
Yeah.
It's gonna be jump.
Okay, it just needs to like not fail now. If it fails now, I'm gonna crash out.
So
Yes.
it won't. It won't. It won't because it can't. Okay. Fourth
Look.
one. We debug and then we lock the. You know what? You can start writing the prime code right
I genuinely have nothing. Like what? I
now. You're the expert though.
yeah, but this, I need to like I would need like at least an hour to come up with something.
That's not very helpful when we have an hour.
This is what I mean.
Okay,
if
for
we
next-
had like an emulator for this.
For
I could-
next prime.
I don't know.
No, but I already thought of it. Remember? We
Yeah.
find the square root and then we just increase by 1 and check every
Okay.
single possible value. We just brute force it.
We've got to type this up together. After
Yeah,
this,
yeah.
I think. That's the plan.
Let's fucking go. And now, yes.
Okay.
Okay. What we do is we go back to the start and we run it and we see what happens. And we
Right.
hope it breaks in
I'm
a
locked
very
in, locked
obvious
in.
way. Wait. Turn on debug. Input. It's not input. I'll turn on. Wait, there was a jump always that didn't jump. There was a jump always that didn't jump. There was a jump always that
yeah,
didn't jump.
because there was no jumping there.
The jump always are not jumping.
Okay.
Jump always are not jumping.
Yeah, because we've got our insert section.
There was an overflow. That's weird.
Okay, so
Wait, that must mean there's a massive ad going on. Jump always. Oh no. Oh, never mind. I was thinking jump always and add have been swapped or something.
No, because we only do add.
But it can't
n.
be.
Well, we add
Yeah.
7.
Because I was thinking something has caused an overflow. So something is added.
Wait, because
over.
we jump to that large address over here because we've got our fill-in section, right?
Yeah. But what I'm
So-
saying is that none of the jumps are happening. There's no jump always. There is no jump always. And the other jump didn't work, but that's a conditional jump, so that doesn't mean anything. But the jump always has definitely been
don't
swapped
do
with
any-
something.
Wait.
So what happens when we
okay.
what happens when we jump always? You know what? I'm gonna go into a different section of the code and we're gonna find out what happens if I do jump always.
Yeah.
So we're gonna load 0 here. I'm just gonna make sure. We've done that. So we've got a 0 in the accumulator.
Okay.
What happens?
Put jump always and then some junk address.
Yeah, I'll put 1.
Yeah, sounds good.
What happens if we run this?
Okay, it becomes 1 in the accumulator.
Which very much seems like instant add.
Put it up to 2 and then it should become 3.
Yeah. And then what we can do is we can instant add and it should jump. So now we should be jumping 2, which means we should be adding 2. That's 3.
Yes.
So I think if we instant add to, then I don't know. Then we go like this. Then we jump.
Yes. Okay. Right. Easy fix.
Easy, so easy. Instant jump and instant add have been swapped.
We've got three jump ways.
We've got quite a few jump ways.
One instant add. That's it.
Okay, we need to do this right now.
Back it up.
I'll quickly make sure you go to that reset. And then, okay. I'm going to go to the start just so we can do this more easily.
Yeah.
Okay, what's our first jump?
We got an instant add.
That's an instant add, which I'm surprised. Oh, it did jump, but it jumped one line, so it was very subtle.
Oh yeah, I was like, I thought that was just like a
Yeah,
drop or something.
I also thought that was like a very fast line there. Anyway, so this instant add becomes an instant jump. Instant add becomes an instant jump.
Yep. Alright, and next we've got
Instant
jump
jump.
always, 3 lines after
Jump
none.
Yep. And this needs to go to an instant add.
And then we've got
Another just 2 lines later.
Yeah. Wait, what?
Yeah, 2 lines later. I've already changed it now, but...
That is not what I've got here.
Oh, what the fuck? Wait, what have you got?
Wait, we
Where
did
are
that.
There was a jump always. That's the going to the extra code.
Yeah.
What was that? What does that say?
That's a divide by 3.
I might have just misread it then. So that was...
that's a 3 right in there.
Yeah, no,
okay.
I just misread it
And
because I must have just not seen the bottom bit.
Then the next none, the line before it is a jump.
Yeah, it does. Well, no, the halt. Wait. Next none.
Yeah.
No. Oh, we swapped 2 lines around. You haven't got that.
Oh, right.
We swapped 2 lines around. You haven't got that, but it's fine. I've got this. So switch that to that,
Cool.
and then we got none, and then output, bunch of stuff, no ads, and then instant jump. Always
Yeah.
jump, which we switch to the instant add symbol, and then it
That's our
works.
test
And then
code.
let me just make 100% sure the counter's reset. Go back to the start. It was an easy debug. If something easy swapped, then it's so easy to recognize. What was the thing that got swapped last time? It was set, and set got swapped with...
It was set and comp.
Yeah, like what the fuck? That's why it took so long for us to notice, because that's such a crazy command thing to switch. This is I believe 3.5 hours we've been doing this now. We're bottom on the leaderboard by so much already. We haven't even done
I
next
think the other people, they planned it, they had their code written, so they didn't have to do all the debugging.
Oh, that might be true.
And then they had to figure out what's what, and that was it. Yes.
I mean, we're doing this fully blind, so...
Okay, pull up Notepad.
Yeah. Well, no, I need to reset all of the code.
Fine, I'll pull up
you need to
Notepad.
pull up Notepad, and you need to start planning something.
Alright, I'll...
This is literally your area of expertise. This is your area.
Okay, right, let's grab an input. Let's set that to our... to our start point. Okay. How do we play this? I think... Because we can't really store a list of previously found finds.
No.
So I think we do just check every other number before it.
Before the square root.
Yeah, before the square root. Oh yeah, let's calculate the square root.
We've already done that. We've already done the calculate square root. Like I said, we find the square root, and then we mod by every value below the square root.
Yeah, and then...
And then if it gets to the square root, if it gets over the square root and none of them have found anything, then it's prime.
Okay, so we need a square root function and one function.
Which we've already done.
Okay.
That's why I say, I don't think this is that hard, we just need to do it, because it's going to be long.
Where is my square root paper?
Did you do it on Notepad?
Ah, this is it.
You got it?
Yeah. Cool.
I love how this is technically your first extreme demon.
Oh yeah, when did you class this as an extreme demon?
It is rated extreme demon.
That's crazy. I forgot we were in geometry, guys.
Yeah.
I was
I forgot we were doing
wait,
that.
I was like, wait, what?
Well, you expect me to put this much time into something if it's not geometry dash?
So factual. Right,
This is the most thinking I've done in days.
right, I guess I will do a function by we just literally have a argument variable that we'll just set and then
Before we call it.
yeah.
We just what we do is we just call it and then we set it and then we call the function.
Yeah, exactly. Okay, so
I'm basically done with resetting this, by the way.
cool.
I've got pretty fast at it. It is literally just like the Matrix coded. Like they say, you look at it for long enough, you start like being able to read it. I can read this. It's actually crazy how much it clicks. Anyway,
okay, I'll modulus.
get out of test mode. Well, I assume we're inputting a value first.
Yeah, I've got that.
Let me just reread this. Yeah, this one's a long while. Okay. Input one number. Input one number. One input.
Okay, wait, we need to return a
wait.
value, so I need to look into this like swap.
We're setting it
Fine.
here. Oh, were you looking at the stack?
No, yeah, because if we're going to return a value. Well, actually, we just...
One number. Smallest prime number that's bigger than or same as n.
Okay. Wait. Yeah, okay. Hold on.
Wait, I'm stupid. I just realised my idea was to check if the number was the square root, the number it was a prime, not to find the smallest. Shit, I just realised that.
Yeah,
No, that's me being stupid. I just forgot the goal.
but it works fine, no?
It checks if something is a prime.
Yeah, so then we just keep checking numbers to see if they're prime.
Harry, how long do you think that's going to take?
Oh my god, yeah, it won't...
I have to execute line by line.
Okay, so we spent ages programming something efficient, or we spent to make it run short, or we spent a short time now to make it run for ages.
Okay, fine.
Wait, but no, we need to run it 5 times.
Yeah, exactly!
Oh.
And we need to debug it in the middle.
Oh. Okay, Well, let's continue making this modulus function. Let me see this swap. Swap the accumulator value at the top of the stack. Awesome. Source. Swap. Right, swap push return. We'll put the address. Wait. Oh, I see. Wait. Ah! Yeah, okay, I got it. So, we swap in our return value. We push that, return that. And then we can pop it to get the result of the function. Right. Now let's make a modulus. How do we do this?
Oh,
We
shit.
start.
Let me see my pants.
Is comp an address?
Is comp...
Comp is an address, right?
Yeah, you give it. It's like direct sub, not immediate sub. Okay, we've got 50 minutes if you're leaving at 7. We're on time pressure now. This This sucked so much with time pressure, but it's because we
Yeah.
took so long on the earlier ones.
So this is something we should have planned, really. Well,
Yeah.
we were kind of hoping to go into it. So, oh yeah, we could beat this.
No, I was hoping it would be like 3 hours because that's what everyone else was. Anyway, okay, we can lock in. Next prime. Are we just gonna do the brute force shit?
Oh, I think we have to.
Yeah.
I can't think of anything else.
So, input number. We check if it's a prime. We go to the next number. Check if it's a prime. We go to the next number. Check if it's a prime. So every time we have to find the square root, and we have to. I mean, we can add some no. I was going to say we can add some quick exceptions by removing like 4 from the checks and 6 from the checks and 8 from the checks.
But that will just the time we save will be negligible at that point.
Yeah. Okay. Well, let's write our square root function,
Yeah.
which we've already done. Let's rewrite the
Okay.
square root function, which
Well,
did
we don't
not.
need to make it a function. We just calculate it.
Let's rewrite the square root.
Oh wait, no.
No, but we
yeah.
do need to do it multiple times.
We put it in the
So the
Is
well, it's just the in 728 is where we're putting the initial input and where we're putting the current number we're checking, which if it turns out is a prime, we just output that. So 728, which we now have stored, we leave a none. We start here. We need to plan this because if we need to go undo anything, it's gonna take so long.
yeah. Okay.
So,
right, I'm writing my modulus function.
well, do we want to write it in Python first?
Oh,
let's run
yeah,
it.
yeah, okay.
I added this. I'll quickly. Okay, num equals. I'll put like 800 or something. Unless that's too fast. Okay. How do we do our square root function?
Is the formula that was like x equals. What's this?
Oh yeah, it was.
It might have been these two reversed.
No, that's right. Okay, so first we need to find the square root, which we do by doing that. Oh god.
Wait, because we've got a small thing, so we can
Oh,
just
yeah.
do like 7 iterations.
No, but it goes up to 1,000.
Oh.
It goes up to 1,000.
Just do 15 iterations.
No. Of the square root, we're only going to do 7. Because remember, it more than halves every time, and we've only multiplied it the max by 4. So for high in range 7,
We need an initial estimate, which is half the number.
well, we need so we need a equals num. Class divided by 2. Then a equals int.
Oh, you can just do the slash.
There's no well for the end for 0.5 times.
Oh yeah.
I guess I could rewrite it, but this is fine. A plus num a. Ugh. Okay. And then we get that, and then we just do that 7 times.
Yep.
So then,
And then-
a at the end is our square root, which then we need to,
Square root rounded down, which we return, and then
which we have, and then what we do is we just we and
Work
then
down from all
we have
of those.
current equals 2, while I'll make it shortened. This is going to be so long in Python.
yeah.
Equal to a, then if num mod, I guess I'll just do it, car, break, oh wait, equals 0. Oh wait, no, but it's like. Wait. Oh,
Wait, what's the-
flag? Flag equals false.
Wait.
If flag, then it's not prime.
If it's not prime, then we just we go
Exactly.
to the
And then plus equals 1. If flag, no. If flag, then num plus equals 1. Else, run equals false. Print num. And now, 809,
Okay.
which I believe is a prime number. I'm gonna quickly Google
Yeah, it's
list.
Well, you just search is 8 or no.
List of all primes up to 1000. List because
800.
because then if we start at 800, oh wait, no wait. Yep, 809. There's nothing. So if
Awesome.
let's say I went like 788, it should go to 797. Yep, this works.
Fine, but this is gonna genuinely take years.
I know. But like, we don't have another option. That took 7 minutes to code in Python. We can code it in this, run it in this, and then debug it in this and run it again.
Oh, okay, right.
Well, we gotta write the square root function, and then we gotta write the mod function.
We
But the
don't
mod,
need-
oh my god, the mod function has to run so many fucking times. This is gonna be so god.
Well, that was why that guy was running his code for so long.
Oh no. Okay.
We're not gonna finish. We're not gonna finish.
We're not finishing.
Okay.
Well, let's see
Let's
what we
try.
can do, because even if you leave and I have to
You
like go
wanna
eat
finish
for an
it off,
hour,
yeah.
I can keep the recording running, come back and finish it off.
Okay, right. Let's finish. This is our modulus function. So we've loaded our first argument.
Well, no, we need square root. Let's write the square root first before we go back to before we even think about modulus. Let's
Okay.
write the square root function in here, because so we have. Do you want the pen?
Amazing.
Okay, we've got input and we've set it. Then we got none.
Okay.
Now it's square root time.
So we've got.
So we need to, because this is the start of the big loop. This is the start of the big loop.
Okay, so wait, we've got to load our
We
our
need
current,
initial A value.
and then so we need to divide it by 2. Div and
Yeah. So then
to
we still have it stored.
set.
Well, no.
Oh, we don't need. Do we need to set it?
Just in case, it is one line.
Yeah, set
Let's
that.
let's load it. Let's load the number, just in case, because it should be loaded. Is this a waste of time? Because remember, every line we write, it has to run every time.
It's fine. Wait, hold on.
Because at the end, we increase it by 1, and then we reset. So if we don't store it at the end, and we don't load it at the start, that's 2 lines we save every time.
Okay.
So I'm not doing this.
Wait. If you write it there, then we
I'm not loading. I'm not going to load it because it's already going to be loaded.
No, but if you write that there, then if we've got boilerplate that we need to add, like extra stuff, we're going to have to move this all around. So we need to write it out first, because there'll be something at the beginning, or there'll be like something happening.
Fine. I'll load it. I'll load it.
Yeah, load the current, guess,
That's set.
divide by 2,
Load the
set
current.
it to,
Then divide by 2.
yeah,
Instant div by 2. Then store it.
right. Yeah, and then we need our loop, so
Store it in A, which is going to be 998. I mean, no. What am I talking about? 727. We got num stored in 728, and we got A stored in 727. What are we doing next?
right.
Oh, then we
this
need
is
to do
our
all the
loop.
calculations.
Oh wait, we need to set up the loop.
I'll add another none. Because that's our initial A value. We need to
Yeah.
run this 7 times. Oh my god, we need the 7.
It's fine. It's fine. We'll just we'll load.
Yeah. No,
We'll
okay.
load this. We'll load it in the node. We'll.
Wait. How about I'll load something that we'll never edit, and then why didn't we do that the whole
Yeah,
time?
and then just subtract whatever.
Why are we?
Wait, why don't we load the current instruction and then subtract from that?
What do you mean?
Like we load whatever number the current
Wait, why don't I load one of our nuns that we're
Yeah,
never
that's
going
what
to
I'm
edit?
saying.
I'm gonna load that line. You see that line right there?
Yeah.
Which is nothing, and it's always going to be nothing. And then I'm gonna add 7. That's 7, I believe. Yes. That's
Wait, why
7.
don't you just put the 7 in the node?
What do you
Then
mean?
you don't need to add anything. You just load there because it loads the bottom 2 bits, and the node, the bottom 2 bits.
I know
don't
what you
do
mean.
anything.
Okay. So instead of this none here, I should have it as 7.
Yeah, just put a 7 in the.
Optimization.
Oh yeah.
Optimization go. This is the stupidest optimization. Okay.
Okay, right, and then that's gonna be our 7.
So then
Boom.
we load the 7 and we store it, and we
In
set in the 726. Yeah, 726, which is the counter up to 7.
Mhm.
Then, oh my god, oh, I'm scared because we have such little time. So now we have a counter, and now I'm gonna leave a none because we have our initial
Yeah.
A and counter. I'm gonna leave a none. Then we have to do it from brackets inwards. So we load number. 2. We load number.
Yeah, and then
And we
we
divide by
divide
A, which is not instant div, it's the other div. So that div
Yeah, and then
by A,
we add A again.
and then we add A. No, we don't instant add.
And then we
We have to direct.
have to multiply.
We have to direct add A, and then we instant mult.
Yeah.
No, we instant div, right?
Yeah. Yeah.
We instant div by 2, yeah.
Even. By 2, and then we store that in our estimate.
Is that in A, or we just update A?
Yeah, we just update A.
And then we set A. And then we need to load the counter. We load the counter. 1, 2, 3. We load counter. And we subtract 1.
Sub 1. Sub n. 1.
It's by 1. Then we store it instantly. We need to instantly store it.
Yeah. In counter, and then
And we set it in
then we jump on
counter.
the flow. No, we jump 0.
We jump of 0, which is jump Z.
Yeah, to
something.
somewhere else, and then we just jump always to.
And then straight after we jump always to which line?
Where we load the.
Yeah, I see it. That one. You see it? This one. Where we load num. I'm not even jumping to the blank space just in case we need to edit it, and in case we need to add something in the blank space. I'm jumping straight into the thing. Okay. Now we leave a none, and then this is after the 7 loop. So we're gonna load straight back into this, which is the function. Okay. I'll move it down a little bit. So this is where we're starting from. Okay. Now what are we doing? Now we have current starting at 2. Oh wait, in the empty space we can set this as 2.
Yeah.
And we can load it. This is the stupidest optimization. I hope this actually works. Then we load the previous line. We load the previous line, we load 2, and then we have to start a loop. Start another loop.
Okay, right.
Yeah.
my brain hurts.
Yeah.
My brain is fried.
So we have 2, and we have another. Now we have another loop.
Loading 2. Where are we storing that? Nowhere.
We're not storing it. Yes, we have to store it. Yeah, we have to store that because we have to update it. Okay. We have to set 725 is current. That's not set.
And then right now we've got to.
Now we have to do our mod function now. We have to do the mod function 1 billion times.
Right.
And if the mod function ever finds that it's 0, then we have to instantly jump out, add 1 all the way back to the start. And if we get through the whole thing without it ever being 0, we go to the exit, print the number, and we're done.
How do we do this?
I know. Well, we need to do mod function. How do we do mod function?
Right.
Oh my god, these are going to be massive numbers. This is up to 1,000,
Oh.
and we have to subtract 2 like 500 times to get to 0.
Oh my god.
This is so bad. This is so bad. We have to subtract 2, check if it's 0, and if it's not 0, we go back up 3 lines, subtract 2. No.
I think it's over.
It's done. It's done. It's done.
Oh.
It's done. But also, even if it takes 5 million years to run,
We've still done it.
like, even if you have to go, I just have to hold
you're gonna have to
W.
debug that.
It's fine. Like, because remember, I can debug it outside. And then, even if you have to go, I'm just holding W.
Yo, what mod is gonna have to review this video?
Hey, Mod, if you're reviewing the video, we're sorry. Actually, to be honest, do they even review, like, completions of this level? Because, like, you could just look up the solutions.
Yeah.
Yeah, like, there's no way anyone's actually
we're
reviewing
legit.
this, because, like, how do you hack this level, bro? Like, so stupid. Anyway, what have we just done? We've just set...
Right, we need to do our mod function.
Have you actually been writing this out?
Yes, it's still here.
Oh, okay, cool. Oh, I feel weak. So we've just stored in 75. We've just stored current in 75. Right, that's the last thing you've done. Do you have that?
Yes, and we've got our current. Right, and then...
We've just stored current in
That's
75. Okay, it's 1 billion subtractions time.
Okay, right. Well,
Okay. So I've left a none. This is where we're going to be resetting.
this is going to be our while loop.
Yes. This is going to be... We're going to mod... And we're going to check... No, oh my god. Do we need to check underflow as well? Oh my god, we need to check underflow.
Wait.
Because if we just check if it's 0, if it never equals 0, it goes past, and it underflows. So we need to check if it's 0 and if it underflows every time. Okay. So, what's the best way to do this? I know the best way to do this! No, I don't know the best way. Fuck. Okay.
Hold on, I just want to check
Okay,
something.
no, okay. We subtract 2, and we jump Z all the way, and we jump Z to the add 1 reset. If it's not that, we check flag for an underflow. No. What we do is we what? There's no jump if F flag is 0? There's no command for that?
Wait.
There's no jump F.
Wait.
That's so bad.
What do you mean? If...
No. I mean, because what would be so easy is if there's no underflow,
Yeah.
then we just jump instantly. But what we're going to have to do is we're going to have our underflow jump and then a jump always, because there's no underflow jump. There's only a jump if F is 1 or 2. There's no jump if F is 0. So we're wasting a line 500 times per thing.
This is so
That's so stupid. We're wasting a line every time just because we're missing a command. Yeah, you remember all that praise we were giving the command set? Fuck all that. Nah. Terrible instruction set. Worst I've ever seen.
Dude, I don't understand though. How has someone else pulled this off in like 16 minutes?
Because they probably had something planned.
But how? What?
You can like you
Do you
can
just
look
make
it
a
up.
massive sieve? Like a list of all of the prime numbers, and you're just like, is this divisible like this? Like, there's no way.
It is possible. Maybe we should have done that.
Wait, yes. Oh my god, we just make a list of
That
prime numbers.
genuinely might have been faster. That's so fucking stupid.
Wait, what, only up to 1,000, right?
Yeah. There's not even that many prime numbers.
Or we should have just done.
We should have just done that. That's like 100 primes.
Wait, if we made like a nice little neat formula for the.
What if we do that now?
Okay, wait.
What if we reset everything we've just done?
Wait, hold on. Let's think about this first.
What if we leave this? Because if what we do doesn't work, we can come back to this.
Yeah, and then build it somewhere else.
Yeah, let's just build. Whoops. Let's just build it here. Let's just
Okay,
build.
Right, let's take our input.
Well, wait. Why not build the list first?
Okay, but we could do. I'm trying to figure out how we. Okay, we could do it like a jump table. So basically, we have 1,000 entries in our table, and we jump to the memory address. We jump to the memory address in the table. So if we want to check if 5599 is prime, we jump to the start of the list.
There
plus
are
599.
168. There are 168.
Okay, and then
Wait. Oh, I know.
and then there'll be either a jump command to true or a jump command to false or whatever.
Oh, I know what you mean. And also, it's 100 to 1,000. Wait, that cuts off a bunch. That cuts off like 25. That cuts off 25. Yeah.
So basically, we just have to make.
We start from 100.
1,000 entries though.
So we start from 100.
Yeah, we just put a little chunk of code at the beginning that's like a jump if it's correct, where it sets it is prime, and then jumps back to our code.
But Harry, that's 1,000
Yeah.
lines. We have to scroll through 1,000 lines every time.
Okay, maybe we just check if it's.
We just have all of the values stored in 168 lines, and then we just check through each. But how do we check?
We load a specific memory address.
We load an address.
But
No, we subtract by an address, and if it underflows, we go back to the previous address.
But can we do? Well, we can do indirect, right? What's the instruction set allow? Because
We can do indirect.
okay, so
Why?
well, otherwise, like, how are we gonna select? We have to hard code what address it is, so we can't do like a loop where we decrement into a list. But we
Well, no, we can.
isn't there like load n or
Because what we do is we start at the bottom of the list, and whatever address that is,
Yeah.
we have a value that starts there, which we load that value and then that's indirect. And if it underflows, we subtract by
Yeah.
1. We check the previous one. If it underflows, previous one. If it doesn't underflow, if it's the first one that doesn't underflow, then that is the largest prime number that is smaller than our number. We increase the address number by 1, and we output that number.
okay?
You see, you get it?
Yeah, I see.
Okay, I
see
need to go to the
vision.
toilet.
Okay.
But
Okay.
this might actually work. But it's 168 lines we have to scroll through every time we reset, which is
It's fine.
we can do that. Well, we don't need to do all the ones below 100. Remember?
Yeah.
So okay.
Well, here's a plan. We need to use uload essentially to load the prime from the table. Because
Yes.
that way we set the location.
We need to use ULOAD. Yeah.
Yeah, and then we uload that.
Okay. So let's start from 101. Let's start from 101. No. Let's start from 97. But just in case they put in 100, let's start with 97, and we'll go up to 1009. So 97. Oh, we need to translate that into. Actually, I'm writing some code right now.
Write some code. Yeah, all right.
I'm right now writing. No, just in case we need this, I'm going to comment this out. And that's actually wait. No, I'm just going to copy paste it into the notepad.
Cool.
Okay. No. Equals input. Wait.
You know what happened? I think what happened is that we started trying to be actually good, like programmers, and we were like, oh, what if we did this well? No.
Yep.
No.
So.
Right.
Int input, and then what we need to do is we need to it's always going to be 0. It's always going to be 0 first. Because it's never going to be more than 27 times 27.
Yeah.
Wait, is it? Wait, you have the calc, right?
Yeah, I got
wait, no, 27 times 27 is less than 1,000.
I don't think so.
You sure? I think it is.
729, yeah.
Yeah. Okay, well... Okay. Wait, so... in range 3 current equals 729 out plus equals string num divided by current plus space.
Okay, and do you know what? This code will be dead simple to debug as well.
Yeah. Well, assuming we remove all the previous instruction. Oh wait.
No.
If it randomizes 2 of those that we're not using,
exactly,
then it'll still work.
That's brilliant.
Wait.
This is literally just loading and then subtracting, and that's it.
Yeah.
It must be fixed, like what ones get swapped around.
Maybe. It's definitely possible.
Because no way, the input was so easy on our first one, and the second one, like, there must be.
Okay, first one. 97. 0397. Wait, 0397. Oh, it's because I'm not subtracting. .97. 0394. That's still not correct, bro. What? So 3. Oh, times, yeah. We already did this. Yeah, you gotta go in like 20 minutes. I should be able to finish this off by myself, hopefully. 0316. Oh, I'm gonna need to manually translate these 168 times. Wait, no, just leave it here.
Oh, yeah, okay. Hold on. Yeah? So loud. Hold on. A second. Yeah, in a minute. Well, how's quite soon? Can you wait longer? I'll transfer it myself.
Oh, okay. Well, I'll. No. Oh, of course it is.
Do you have to go?
I have to go in like 10 minutes.
That's fine, but because I should be able to finish this myself.
Okay. But then, okay.
Well, I need to see this.
Oh,
I need to write them.
Do you wanna?
So this should be 97. I have no way of testing. So if I get a single one of these wrong, we're fucked. Which is why I feel like this might be a bad solution.
Well, how many of them are there? There's
140. 101. Yeah, I don't know about this, but you know what? If it doesn't work, then I don't know. Because if we can't do this, we've wasted a lot of time.
No, it was fun.
It was very fun, yeah.
Time well spent is not time wasted.
True.
Well, I don't know what I just said there. I'm waffling.
No, it's true though. Oh, I need 103 now. It's pretty obvious what it is, but.
Oh yeah, no, it's
107. Wait, 0326. Have I fucked up this code? Because that shouldn't be. No, 26 is correct because it goes up to 27. Sorry, that's my bad. So that's correct, and then it's 109. Thank you. 41. It's going faster now. It's 19. And then 423. Wait, yeah. 52. Yeah. We're not that far in, are we?
no.
But there are less and less the more you go up, so.
That's true. You need to scroll across, by the way.
Huh? What do you mean?
Like I can't. Yeah.
Have we already done 151? Yeah, we have. That's 22. It's the one after that, which is that, okay.
167.
Because the thing is, if this doesn't work, I will have wasted so much time.
Yeah.
You know what? Why did I build it like this? Why didn't I? No, why don't I just need to redo the? No, this is stupid. I think. No, I can make this way better right now. I can make this so much better right now by doing this. What were we just doing? What number did you just put in? Harry, don't you fucking dare. You're the one putting them in, how do you not know?
I think it was 173.
Let me check. Well, because the thing is, now I can check.
Well, because I just said 67.
001. Then we have this one, which is 167.
Yeah. Which is that's what I just said.
12, and then because you see how this is so much better, and now the next one we haven't done, 173. Yeah.
And then you'll need to go across again.
It's not encouraging.
Nope.
Because this is still a really terrible system, but it's better. Oh, and then I at least I know where I started, so... Well, it doesn't matter where I start, it matters where I end. That's a lesson for life. That wasn't planned. No, I really should have put, like, both translations. So I could have had it backed up, but... Did you just put that one in?
Yeah.
No, I just did that one.
Oh, 191.
Yeah, I just did that one. This is terrible.
No.
But it's not even like, well, I haven't done 193 yet, bro.
You just put both in so that...
Yeah, but I don't know which ones I've done yet.
Oh.
It's not helpful.
Yummy.
It's really confusing. You just make it so
well,
much
I
harder.
can't tell when you've done it or not.
Yeah, you can't read it like I can.
I haven't been entering it.
Yeah, I've been entering. Because I like entering, yeah. We're good now.
Okay. Oh, I can't use this table. This is... I keep losing where I am.
2-on-1. No way, like the level. If I get a single one of these wrong, I'm so fucked.
Well, no, because there's a low chance that...
I'm not done yet, by the way. This sucks.
Yeah. Okay, I low-key have to dip.
Yeah,
Okay,
I understand.
Shouted at. No, I thought we could finish it off. But
Well, I should be able
that
to finish off tonight.
You
Even if I'll have to
tell me how
AFK
this
for an hour.
goes.
I might have done AFK for an hour to do it, but
yeah, it's true.
yeah. Well, I'll see you all.
All right.
Well, you want to say? Wait, did you finish this?
Yeah.
Well, that was. That was good. That was. I never knew you. Just me now. My helper is gone. Okay, 2-2. 22102 is done. Two two one one one. 22111. Okay, what's the next? Altitude 9 is 233, which is 22122. We were making like an actual coded solution and we were like, what if we just didn't? I feel like the other way might have actually just been better. Might have made a mistake doing this. What have I just done? Oh, I just did the same one again. What? I still don't think I've done 269. Yeah, I haven't. This is such a bad idea. This is such a bad idea. I'm not halfway yet, but I'm not far. As in, like, I'm like 3/7 of the way done. No, I'm not. I've done like almost 30, and I have to do 140. So yeah, no, I'm like a quarter done. Wait, I just realized I'm stupid. What am I doing? Why don't I just do this? This is so much smarter. close, they get a bit mad. Done like 55 now. So coming up on halfway. A lot less fun after I stopped coding. Put some music on. Okay, I gotta go for like 30 minutes. Sorry to anyone actually watching this. I'm back. 5 hours. I'm using listed shit now. It's an achievement. I'm actually really scared about the recording. 5 hours, 40 minutes. If I actually got a prime wrong, it would have to land on the prime I got wrong. Oh my god. That's all of them. Jesus Christ. I'm not done yet. This still needs to work. Oh my god. Okay. God. I'm stressed now. Okay. Well, I guess we can start the code here. No. Oh, we give more space, okay. Need an input. I'm going to store that. Oh my god, I actually need to put the documentation again, it's been too long. Set that in, I'll just go in there. No, actually, set this to the first address, and then what we'll do is we'll load that. And we'll load that, which is the first address, and we'll store it in the address before it, so we back up. Okay. Okay. Now we need a loop. So we'll load a prime, we'll subtract the number until we get an underflow, because then the number's bigger. We'll go back to the previous address and we'll output it. Okay. So we need to uload, which I've not used before. Uload the address contained in the one that we just set, which is this, not the backup. We do a direct subtraction from final. I'm listening to a really good song right now, so it's not helping me talk. And then if we get an underflow, if we jump UF, if we get an underflow, I'll leave it for now. If we do not get an underflow, then we need to load the memory address and subtract 1. Like load the address of the memory addresses, so instant load. We need to directly load this, and then direct immediate subtract 1, and set it. Wait. I feel like I've been distracted. We've just subtracted 1. Now we need a set in the address. This line is the one we're going to. Just this. Now we need to load the address again. Immediately add a 1. Oh god, this is so finicky. I'm gonna mess something up. This isn't gonna work. I'm really stressed that this isn't gonna work. I really want it to work. And I'm not like taking notes or anything, so if it doesn't, then I just have to kind of deal with it. Oh, debugging's gonna suck. And then we need to uload. And then output. Okay. Fuck. Double space. Well, here goes nothing, I guess. Please work. It didn't work. Oh, wait. Oh, I'm done. If there's not an underflow. Oh, yeah, I forgot that this is, like, annoying. Okay, I have an idea. I have an idea. Okay, let's reset all this. Which is a little bit annoying, but it's fine. As long as it works in the end. That's what matters. As long as it works in the end, I don't care. I just need it to work, because I can't deal with having to, like, reset everything that I just spent, like, 2 hours doing. Because if it doesn't work, then it doesn't work, you know? As dumb as that sounds. Like, I might genuinely have to give up. Like, just completely just abandon the entire day of working on this if it doesn't work. So if there's no underflow, then we need to output and leave. So if the jump does not happen, okay, then we're ending. If the jump does happen, we're not ending. Which means I'll need to put an always jump after the conditional jump. So the conditional jump will jump to an always jump. Otherwise, it's going to keep going as normal. Let me find some music to put on. load the address. Instant add 1. Set in the same address. Now we need to load the same address. Output and then halt. I forgot about halting, but before. Oh, wait, that's nice. So now, if it's this, then we kind of do the same thing, except we subtract by 1. And we just have to normal load the address. Oh, I hate this. I'm actually really stressed. Immediate subtract. Store it back. Jump always. To here, right? God, please, please. Why don't we get on the fly? He didn't jump. So load this, set it in here. This should load that. Yep, that should be how that works. Am I fucking stupid? We're grabbing the prime number and we're subtracting. Did I undo it when it was correct? Oh my god. This is why I need Harry. I think it was right. So I'm taking... as a test. I know what I did wrong. It was fucking correct. See, that's oh, I need to undo the changes I just made, so that sucks. So if it doesn't underflow, that means we need to keep looking. I need to turn off the music. I gotta focus. God. I'm just so stressed this won't work. If it doesn't underflow, then yeah, I need to... Oh, I'm stupid, I'm stupid, I'm stupid, I'm stupid, I'm stupid, I'm stupid. I'm so dumb, I'm so dumb, I'm so dumb. It was fine, it was fine. Okay. God. Instead of subtracting, no, instead of adding, I need to subtract, then set, and then instead of U loading, and delete that, and we need to delete the out. We need to delete the whole. And we need to jump always. You know, I can check what I do. Just do what I did down there. So that one. And that should all be the same. Yeah, that's all the same. Instead of this, add. Instead of jumping always, I need to U-load from the correct address and output and then halt. Please fucking work. Please work. I think it's working. I think it's working. It's still going to take so long, but I think it's working. I think we're going to have to go a long time to find this. I think we're past, yeah, we're past the first. I hope this works. I beg this works, and that she actually, and that it actually works, and that I don't care if I have to run all this 4 times as long as it works. Oh, I can see the address wrong. Holy fuck. Hopefully they pick some higher numbers for the next few. And do not mess this up. Start from the correct place. Bang. I think this number's 16. I think it's like, so 16 times 27, it's like 400. If my recording breaks now, I swear to God. Because I'm actually going to upload this full thing. So it's easy. You know what? I'm going to... It worked again. start with the input. Bang. Speed up. Yes! It's time. It's time to see what the hell got messed up. It's time to see. Okay, well. It's about to call Harry. No, oh, okay, he's just finding his mic. Okay, well, I guess I'll run it again. Well, I'll run it out of debug. Input's been swapped. Input's been swapped. Oh my god, input's been swapped. Wait, that's so free. That's so free. Input's been swapped. Okay, what happens if I run this? Okay, what if I input 2? What if I... Wow, that massively... I think that overflowed. I think... Okay. Load... I think it's been swapped with subtract. I'm gonna load a 0. Or is it like loading? No, it can't be loading. What is that value? It's a big value. Where's it getting that value from? Okay. Input is doing something. But I just don't know what. Okay, I'm gonna load 0 up. And then if it was input 1, you get 1. If it's input 2, what the hell? So if you input 1, 0 goes to 1. If you input 2, some insane stuff. Oh, Harry's calling. Yo. Yo. Oh, your mic is messed up. Your mic's messed up.
Better?
Yes, that's better. Okay.
Right.
Input has been swapped.
So you can
But it's, I don't know what it's been swapped with. Do you want me to screen share? Do you want me to screen share?
yeah.
I'm just gonna share geometry Shash. Okay, so so I have this. So this is my input line. So I'm gonna load 0 real quick, and then if I load 0, you can see it underflows to 1. Like it underflows to 1. If I put in 2, then it just goes to some insane value that's not an underflow. I don't know where the hell it's getting that.
Is it position 2 in memory?
I think it might be like multiplying by like that position in memory or something.
Yeah.
No, it can't be. Okay, because see, I don't want to go all the way down there, but like If I put, oh yeah,
Basically, because it's input, can't you just try a bunch of things and then whatever stops the program, you know?
good point, good point, good point. Oh yeah, true. I can go the other way. I was just thinking, what if I do it off this memory address? Like, I'm gonna try this just to see if I can get like an easy solution here.
Is that B?
That, huh? Two. It's loading two. It's loading two.
Oh, two.
Yeah, it's loading two. And then if I start this, it's gonna load 0. Yeah. Yeah, I don't know. It's something strange is happening. It might be like you load. That is definitely possible. It might be you load. Let me put a uload command. Let me put uload, and then if this inputs, it did not. It did not input. It's not uload.
Try like okay, it's not immediate. It's nothing immediate. So
Yeah.
maybe malt.
True. I'll try malt. Well, actually, no. I'll just go through. I'll go add. It won't be, but it's not add. I'll try. Sub. It's sub.
Okay.
It's sub. Okay. So sub is input.
Okay, now you just gotta wrap this up.
Yeah.
Nice and neat.
Okay. These are my tests. Let me just delete them because you know what it is now. Okay, that's the hold. Okay, back to the Salzburg. Okay, that's the list.
Okay.
So this input needs to become sub, which is 12. Back. Okay, where do I have a sub? I actually don't think I have one in the program. No, I do. Yes, I do. This is a sub. Let's change it to an input. And I believe that is the only one.
Okay.
Well, you're going to see how long this shit takes to execute now.
Like this is it.
Yeah, this is it.
I believe.
Okay, and now I have to hold W while this executes. Okay, it's looping correctly. That's a very good sign. And if you see,
Why is the beginning of your program like?
you see the address here. The address here is decreasing. We're going up through our memory list of primes, and we're getting ones, but we're not getting underflows. You see, this is updating correctly. I think it's gonna work. So you see, this is the input here that we're trying to get to. This is 19 times 27, which is, let me check on my calc. 19 times 27.
What does calc stand for, by the way?
I actually don't know. I'm new to the chat. I'm actually not 100% sure. I've just heard people saying it, so I wanted to like say it to begin with it. Do you know what calc means?
Oh yeah. I don't
No,
know.
it's an unknown.
Not too short for
Anyway, it's around like 520, I think. So not as far as the others, but still quite a ways to go. I think this might take around like 3 minutes. But hopefully, after I hold W here,
Fingers crossed.
we will be done. We will be done with the level. Oh.
Is there a coin in this level?
Is there a what?
Is there a coin?
Is there a coin? I actually don't think so.
Yeah.
I didn't check. Yeah, let me exit out of the level right now to check.
Yeah.
I was so stressed that the list of primes wasn't going to work because I spent like 2 hours writing it. It actually took so long.
Hopefully OBS doesn't run out of storage.
Huh? Yeah, I like had to make sure it's recording. It's been recording for like 6.5 hours. My dad said I'm not allowed to upload it to YouTube until night because he doesn't want me ruining the Wi-Fi. But I might do it anyway.
That is a slow run and a half.
Yeah. Current last place is like 2 hours 55, and this is a 6.5 hour recording. Like, you know, did I sent you that video of Dusty Travel, right? You know, the desert bus level.
Yeah.
This is like as long as it takes to beat that level. This is longer, actually.
Wow. The time we've spent.
It's because we've been locked in. God. Okay. Yeah.
I love the sound.
We did it! That's it! Oh my god, we beat it! We actually did it. Holy shit.
Oh,
It's done. It has 3 coins? For what? I would have gone for them. Holy shit. That's it. We did it! We did it! Oh my god. Okay. I'm gonna end the recording 6 hours 37 minutes. That's insane. Okay, well, bye everyone. If you chose to watch this for some reason, bye.